Alright, I think we are live. This time I actually have to make sure the chat works. Because last time I went like 20 minutes without seeing the chat. So, hopefully we get lucky this time. Okay. Wow, that was fast. Welcome to the stream. I haven't even gotten the chat working yet. I need to test it. Okay. You were so fast, I don't even have the chat working for you. Alright, I think we're good though. Let me test Twitch as well. Because I do this dual stream thing where I have Twitch and YouTube combined into like one chat. And earlier in the week, it didn't work. Okay, it's working today. Sweet. And hopefully I'm not dropping frames as well. Sometimes my internet craps out. All right. All right, so today I've got a lot of work to do. But hopefully it should be kind of fun work. Though not too visual, unfortunately. I'm finally starting to work on getting Metal integrated, like as a render backend for Mac. So I have my Mac here on like a remote desktop, and I can run Metal, and I get a a red screen, which is the full extent of my Metal backend at the moment. But the fact that I even see any color at all is a good sign, because that means like my window is like correctly communicating with, you know, the graphics card, I guess, the device. And I'm like rendering to a swap chain. I haven't actually tested this. Let me look at some stuff. Because right now I have this just like really hacked in here. I need to jump up a project. So in my frame begin function, or begin frame, oh, I have full word check on. Yeah, so I'm just setting the color here. So like in theory, if I include, it's so, I'm like working through a remote desktop. So I'm getting like this lag in my input, and my Mac isn't giving me autocomplete for my headers. But if I just do like, I need to create a random. In theory, if I randomize these every frame, I should get like spammed colors. Yeah, there we go. Seizure mode activated. Okay. Yeah. So basically what I have to do to get Metal to work, right, is I have, so this is my Metal backend renderer thing. And I have all of these functions. So like, we have handling uniform buffers, we have textures, we have render targets. But you can see all these functions have nothing in them. They're just like basically stubs that don't do anything. Except for the very basic like initialize the renderer and create a swap chain. So to get Metal to work, obviously I need to implement all of this stuff. And I'm definitely not going to do that today because that's a lot of work. But one of the important things to actually make any progress at all is I need to get the shaders to work. So I'm working on the shaders today. But like for context, this is what the DirectX backend looks like. So it's like 2,000 lines of just random graphics code. for handling, texture resources and vertex buffers and all that fun stuff. But today I'm working on the shader language. So generating the metal shader code from my, I guess, universal shader language I have. So yeah. About 2 years, on and off. I work mostly over the winter and the fall and spring months. So I would say it's a year of actual work, but it's been spread over about 2 years now. And even that's working on the weekends. I don't have infinite free time, unfortunately. But yeah, so this is I did a bit of work off stream to kind of prep for this. So this is one of the shaders, but I've actually run it through ChatGPT to convert it to metal, just so I get at least something basic to reference while I'm generating my actual shader code. And then I have the metal docs up as well, so I'm going to be using this. So yeah, I'm just going to get started. So metal's kind of interesting. I don't know how much you know about metal or anything, but they have their own shader language. So GLSL, HLSL, and then Apple has metal. And the kind of interesting thing about metal is they built it off of C++ 14, I believe. Or they use a C++ 14 compiler, I think Clang, but they have their own extension for the Clang compiler, which they use to actually generate their shader bytecode. But they've designed their shader language to basically be C++. And I don't know what happened to my file association. So the way you pass around textures and buffers and stuff is through function parameters. And you can see there's pass by reference. So yeah, it's kind of interesting. The way they design their language, because HLSL and GLSL are much more like C in how they do things, but then there also is some global state that they just access. But generating metal shader code, you have to think more like C++. So I just made this test shader. So here's my little test project. It's just really basic. But I have a little test shader that I'm going to be working on, which has some stuff. So this is my shader language, by the way, that we're looking at now. And all the shader does is just samples the texture and applies a color, and the color's driven through a uniform. So in the shader here, I can actually change it, or in the game here, I can change the color that it's being overridden with. But right now I'm on Windows and I'm running with OpenGL. So this is what that shader looks like converted to. Yeah, it was. Yeah, it's all with my own shader language. So this is what that shader looks like in GLSL, because obviously when I'm running OpenGL, it needs to be a GLSL shader. So the little compiler converts it to GLSL. And then I can switch to DirectX and recompile. So now we're running in DirectX. And then you can see that this shader got regenerated. So now this is a HLSL shader. Yeah, so then essentially what I have to do today is just do the same code generation, but for metal. And thankfully it's not drastically different. There's some of this I'm going to just take from what I'm doing in HLSL, I guess, because some of it's similar. Yeah, pretty much. Yeah, I always say compiler. It's not technically a compiler, because it's not doing a lot of the stuff compilers do. But it is like parsing my language, building like the syntax tree, and then when I generate the backend code, it's like retraversing that tree and generating the specific output for each language. It also does some other stuff too, with like generating some C++ code for like the vertex formats. They require just sort of boilerplate binding code. I don't have CUDA yet. So like right now it's just HLSL and GLSL. And then today, obviously, I'm going to try and get Metal fully implemented. But in theory, you could do, yeah, any language, I guess. Like, the sky's the limit, I suppose. It's okay, so let me see. I need to turn back. I have this little debug flag here. So if I turn this on, I won't actually like be able to run the game anymore. But with this on, I actually generate every backend at the same time. So if I go back here, so with this mode, and I'm just like writing these to a file so I can actually see what they look like. It's not actually a requirement that I write this to a file. But yeah, so here's like the GLSL. It's kind of cool because you can like see them directly side by side. So like, you can see the differences. But yeah, Metal doesn't have any special logic. It's just like directly passing through the input shader to the back end for Metal. So yeah, I guess the first thing I need to do is basically do the, where do I print this? But yeah, I should say, I'm kind of repeating myself because on previous streams I've talked about this too, and I'm not sure who was there in the previous ones. But like this cross compilation of shader languages isn't like a new idea. Like there's a tool called SpurV Cross, developed by Kronos, I think. So people do Vulkan. And with SpurV Cross, you can take basically any of the high level, like any like HLSL, GLSL, or Metal, and cross compile them to like each other. So it's not like this concept is new. I'm not using that just because I think it's more fun to write it myself. And I do some other stuff that SpurV Cross doesn't do, just for like my engine specifically. Okay, so we need to go to the Metal generator. So yeah, so each like language has its own generator file basically that runs. So where do I do this? So I don't even have a generate stage for Metal, so we need to do that. Yeah, see, my Metal generator is basically nothing right now. So we get a stage, and I just copy this. Metal, where is that? Yeah, I have nothing in here, wow. Okay. All right, so Metal shaders at the top. I guess they don't expect this, but I'm going to do it because it makes life easier. You have to include these. So, in theory, our Metal output should now have that on it. I might need to rebuild. Yeah, there we go. So that contains, why does my language association keep resetting? Figure, oh no, I didn't mean to do that. No. C++. Okay. And then our vertex formats are just structs in C++, it looks like. Or no, we have these attributes. Okay. I figured, let's look at the docs. So what does vertex input expect? So these are just attributes. That's interesting. Yeah, because each language does this in like a kind of unique way. So like in DirectX, you have like the semantics you need to specify. So if we look at where did it go? I wish I had this easily accessible all the time. Like DirectX, you have these attributes you have to tag on. And the only one here that actually matters is the position. Because a position is required. Well, actually, no, it's only required for the output to have a position. But these attributes actually don't mean anything. You can write whatever you want here, which is kind of funny. But yeah, so metal has these as well. So we need to find out where we print those. So generate structure, defects vertex. Yeah, so we need all of these. I'll just steal these from HLSL. It's actually a lot of code, wow. So generate stage. It's 1440p. 1440 in 144 hertz. I actually used to have a 4K monitor. I used to have two of them. Actually, it's set up in the background back there because I have a different little computer running. I used to have a 4K one, but I didn't actually like it that much. Well, it was a 4K 60 hertz, and then I was looking at how expensive are 4K 144 hertz, and they are pretty expensive, or at least they were when I bought the monitors. And I'm like, I don't know. I'd rather have the refresh rate than the resolution. Okay, so what are these semantic things? Let's see. So this is generating the let's see, what is this? Oh, were you the one that brought that up to me, actually? Sorry, I'm bad with names. Yeah, because I looked into that too, because I thought it was the DPI scaling. But I wasn't able to reproduce it. So I think... I think it is still related to that. I just need to figure that out. It's annoying because it gets really in the weeds here, but Windows 10 and 11, there's a flag that you set when you start your application and you like initialize the window. Let me see if I can find it quickly because it's kind of stupid. So like in my window code, basically the DPI scaling is enforced by the operating system, but it's not always enforced. And applications can actually override the scaling. And I think I was doing that. So like if I go to Windows, there's like some flag in here. I probably won't be able to find it when I'm actually looking for it. I guess it doesn't matter that much, specifically what the flag is. But there's some funny thing in the docs where, there's this function you can run when you initialize your window with like the Windows API that turns off the DPI scaling. But in the docs, there's this funny thing that's like, this doesn't always work on Windows 10 and 11. So there's a separate setting you're supposed to put in the manifest file. And for context, what the manifest file is it's basically like when you want your executable to have an icon and all like the extra information, when you like right click, like look at view information, whatever it says, you have to have this manifest file and you have to like run this little program that links the manifest file to the executable and, you know, bakes in this information. There's a flag you're supposed to put in the manifest file as well, I guess, to make it more reliable. But it's like this whole fiasco just to like prevent Windows from messing with your pixels. Yeah, I did. Here, let me see if I can reproduce it, because I know exactly what you're talking about. I might need to turn this back off. Where am I? Keep jumping around. It's the problem with having all my projects in like one thing here. So I need to turn this back off. Clear this. This should run still. No, it doesn't, because I've messed up stuff. All right, 1 second. Bear with me. Doesn't like this function. And this one. Really? Generate structure. What's it mad about? Yeah, I think it's actually a Windows problem. But other apps don't have this problem, so it's also like partially a me problem. And it doesn't surprise me that it's not working. Oh, I already had this function. That's why. Do I already implement this, actually? Metal. Oh, I was already implementing this. Okay, let's see. Okay, that should work now. I guess not. Did I not change this flag? Oh, that was the wrong flag. I need to change this one. Yeah, here we go. Let's go to the globe project. I need to rebuild. Yeah, here we go. And I guess it's hard to see on the stream because the text is so small. But like, this is, you know, this is what I expect. I do have the text really crammed up in the corner, but it is like aligned with the edge of the screen. Now I assume what you're talking about was like if I go to display settings or whatever it is, window, monitors. What's the setting for your display? Here we go. Yeah, you can like go in here and change the scale to like 150. So now I'm at like 150 scaling. And I like rebuild. See, this is still like correct for me, right? It's just like squeezed in. And then I guess like if I change this while the app is running, I don't know what happens. Like that's like still correct. Yeah, so I think the problem is that I'm like calling that function to set the flag, telling Windows that my application should have control over the scaling of its I guess window swap chain, its canvas to render into, but it doesn't reliably work on all Windows versions. So I need to do the thing with the manifest. Thanks. I need to do the thing with the manifest. So I'll look into it. I should test on a few other Windows computers. I'll send it to some friends or something. Maybe they can reproduce it as well. Okay, so back to this. Gotta turn this back on. So what does my output metal code look like? Back to the metal project. Clean build. I don't. I don't have a Discord server. You can add me on Discord if you want. This is my Discord. Yeah, if you're willing to help me test this, that'd be actually really awesome. Probably not today because I'm working on this shader stuff, but I would appreciate that if when I get around to trying to fix it. Oh wait, what am I doing? Okay, so generate the shader code. Metal output, generated shaders, metal. Okay, so I don't know if this actually worked or not. But my goal is to have this structure look like, well, I guess not this one. It should look like this. The goal is to have, let's see. Oops. What's this? Here we go. Like attribute. Zero, 1, 2. And then this one needs to look the same, except this would be like, I guess, position. So it needs to specify position. Now what do the other ones need to be? User, location 0. This needs to look like this. I wonder why it's position 0. Alright, let's see. Yeah, or actually no, you don't need to specify the user ones, it looks like. It's just position. Okay. So generate the structure. So the vertex input instance. Where do I have vertex? Here we go. So I need to delete a lot of this. This is on irrelevant. Oh wait, this isn't even the right function. What's going on? Does it just generate structure that I need? Oh yeah, here we go. So I think this is actually just fine being like this. So it's like position, or what's attribute dot I dot append. So if we regenerate this, I suppose this isn't the most thrilling stream content. Generating shader code. All right. I haven't seen any Twitch chat. Am I avoiding Twitch? I'm actually scared because my chat didn't work last week. I think I said that already. I'm like paranoid now that I'm missing. No, I think we're good. I think we're okay. All right. Output generated shader metal. Yeah, here we go. Kind of. Now this needs to change based on, oh, it's interesting. It's counting up like infinitely. Or so I need to actually be a little more careful about how I'm doing this. So if struct type is equal to the vertex input, then we append the attribute. I guess I can switch on this because it's going to be the same. Case. So for writing the input stage of vertex, we just do like that. Oops. If we are the output stage and the input for the fragment, then we actually don't need the locations, I guess. So only if the type I forget which of these it is. Is it the variable? Dot semantic is equal to. So only if it's positioned do we actually care about the attribute for this guy. I don't know why I have an extra space here. So this would be position, I guess, 0. And then I needs to be something else too. So like, let's call it slot. This needs to be slot. I guess this technically isn't correct, but I will also do this. I hate Visual Studio because I hate how clunky it is. It's like really slow, like to open up. I hate the hotkeys. I'm not a big fan of Visual Studio. And I love VS Code because I can customize it, and it works VS Code works on Mac, it works on Linux, it works on Windows, it works anywhere, pretty much. And I do cross-platform development, so like here I am on my Mac. I have a little remote desktop, and it's great because I can just have the exact same experience on my Mac, right? It's awesome. If I'm working on Mac, I want it to have the same exact build experience. So that's why I use VS Code, because it's just nice. It's great. I love it. I'm passionate about this. Okay, let's see. All right, there we go. Looking good. Looks exactly. It's a custom theme, actually. I just kind of like did it myself one evening. The font, though, if you want to know the font, I can write that in the chat because it's a nice font. IO Sevka, it's called. And then I just changed like the background to be a little darker than the sides. Okay, so let's see. I guess I could. I don't even know how to do that. It's like in my preferences. JSON file. The problem is it's like, I guess all of these, I don't know. It's like mixed in because you know how VS Code kind of like just plops all this stuff down. Yeah, it's a great font. I love it. Okay, so this is the vertex output, and then the input should match that as well. Now, is this actually up to spec? I'm kind of doing this blind because I don't have my I don't have my metal shader compiler actually implemented yet in the engine, but I want to do this next. But I want to get like at least most of the way there before I really start getting deep. So let me see. Or I guess vertex input, output, I mean. Yeah, so it seems like you can just pass. It's like I'm basically copying this right here, right? Wow, this highlighting is not working. That's not where my mouse is. So this looks pretty simple. This is crazy. Look, you have like these like a const x per sampler. It's so weird seeing a shader language that's like using C++ kind of lingo. Does this actually need to say vertex? I guess it does. And what does the fragment output look like? Is there a fragment output? Yeah, here we go. If you have multiple color attachments, you have to do this. I don't think this color attachment thing's necessary. That's only if you're using this. Yeah, I do want to get. I want to implement Lua to the engine at some point. It's not a high priority for me yet because I'm not really making games at the moment in it. But once I start making like actual games, it would be nice to have scripting support. And like mod support as well would be nice. Because like right now you can't really do any modding unless you like directly mess with the binary file for like the assets. And even then it like really expects a rigid layout, so modding would be kind of a pain for people. So having just like a more friendly experience for how assets and stuff get loaded in would be nice. Yeah, it is. Yeah, I don't have any plans of like turning it into a product per se. Like I'm just doing this for fun, really, as a hobby. So I do have the source in the in the description. There's a GitHub page for it, and the source is fully out there. Okay, yeah, let me look at that. Yeah, I see you sent a friend request. Let me see. Yeah, Discord's weird how it doesn't send. Can you send it again? It's not showing up on my side. I think it's because I didn't accept the friend request in time. Okay, so let's see. So I have to do the fragment output, which has different color attachments. So fragment output. Interesting. Yeah. And the problem with turning into a product is that, like, I'm just one guy, right? And, like, I want to make my own stuff too. I don't want to be spending all my time, like, doing bug fixes for random, you know, people that are using it. Like, it's easy when I fix a bug for myself because, like, obviously I have control over the full code base, and the only code affected by my changes is, like, my own code. When you actually release a product for real and people start using it, it's like, then you need to think about, you know, how stable is your API, right? You don't want to be, like, breaking the API every time people use stuff, like, or, like, use it to actually make stuff. So it just becomes a lot more, just a lot more complicated. Yeah. So if semantic type is color, I guess I could outpen the slot here and slot there and the slot here. So the output for a fragment is only color and depth. Maybe I should have, like, here, let me, need, like, some error checking here, scene depth. Actually, no, that'd be in my front end. I would check that error. So this is fine. So if it is a color, then we specify color. And actually, I have the slot for color, so this needs to be node dot, or not node, slot. And then this would be just depth. This needs to actually be any, because it's tells metal it can write to any depth. I can put that back there. Otherwise, this is an unknown output, so I'll just error. Oh, we didn't like that. Unexpected fragment type. What? Oh, else. Here we go. Yeah, cool. All right, so these are looking good. My basic stage things. Now what's next? So metal expects you to pass. Oh, I need to do the sampler as well. Let me think. Yeah, here's the difference between them. So in DirectX, in HLSL and GLSL, these both behave the same. If you're using like texture slots, not bindless, both of these languages, the textures you like define these in like kind of global namespace, I guess. Right? So like in GLSL, you have this uniform sampler thing, and then in HLSL, you just specify a texture and then its sampler state. And these are globally accessible throughout your shader. But if you have, in Metal, you need to pass these things in as function parameters to like the entry point, so through main. So like this is how you access the texture. And it's the same for the constant buffers as well, is you pass these in as like parameters. And then if you want to use them anywhere in your shader code, like in nested functions, you need to pass these guys around. So there's no like concept of global state in the Metal shader code. So essentially I have to emulate it by, what I'm going to do is I'm going to generate this struct here that I'm going to call a context. And then in the entry point, I'm just going to fill in the context with like, you know, the payload, all of your global things. And then I'll just pass the context around to all the functions that want it. And I think that should basically do the same thing for me that like the global state would do. But this is different than how I've been generating the shader code. So I need to do that. But first, I need to look at yeah, I see what you mean with, yeah, sorry, I just looked at that picture again. Yeah, I see what you mean with the text on the right side. Yeah, that's really odd. Okay, so I keep jumping around. So also Vertex has, where do they have like the Vertex main Vertex input? So I'm looking basically at their example shaders and just kind of matching. But like here's their Vertex. Oh, this is interesting. Their Vertex has a void pointer, or a void return type, vout. What is this? Vertex function with resources and outputs to device memory. Oh, that's so interesting. Does DirectX have like an equivalent concept of this? Yeah, so this example, there's just so many edge cases to think about. Okay, so let me find, so like in this example, you see this is their Vertex shader, their Vertex like main here. And they have this Vertex output, you know, struct that they write to, wherever that thing is specified. I don't even know where it is here. Here it is. They have like this struct, you know, and they're filling it out. Like here's the position, the color, the texture coordinate. But then rather than actually like returning it from this function, I guess to send it directly to like the next stage in the pipeline, they allow you to write it to a buffer directly in GPU memory, which is really interesting. I wonder when you would use that from a Vertex shader, because that's kind of how like a compute shader works, is you have some buffer on the GPU that you like read from and write to. It's interesting that they allow you to do that with the Vertex shader, but I'm probably not going to support that unless the other languages can do that too. Yeah, because this is what I expect the behavior to be. You have like a Vertex output and you like fill it in, and then your input to your, what is this? for input and vertex function. Oh, you can have multiple vertex inputs. One's for, like, from a buffer, and the other one's from the stage. I guess I'm not going to worry about that right now. So where do I make my main function? Generate stage main pipeline. What is pipeline in this case? Oh, this is like the, I guess I should call this like raster instead of compute or pipeline. Yeah, so I need these functions as well. Those are where? I'm actually gonna steal the HLSL one from this because that's more similar to what I'm after. So function main, and then compute, then block. I need to move this up. Should be up here somewhere. And this can be there. Input, instance input, vertex input. Delete all of this, I believe. So all of these are structs as well. Yeah, so I need to pass the context. Pass it as a reference, const reference. And then, do they support these in-outs? In-out, match case. No, they don't support in-out. It's probably just a reference, I imagine. I'll turn those off for now. And then, so that's right. What is this? This substitution thing doesn't seem relevant right now. I guess I just haven't thought too deeply about that in a while. Are you looking at the code? Are you talking about, let me see. I'm not even sure what you're talking about. Thread, maybe you're probably talking about this thing. The concurrent queue, maybe? Do I even implement this? I don't even implement this. Oh yeah, I do. Yeah, I use mutexes. Yeah. I mean, yeah, I don't know. I just haven't. I haven't really thought too deeply about this in a while, so I don't have an answer to your question. I mean, the obvious answer is that using a mutex is just easy to write code for, because it's like you kind of just know that whatever happens in here is going to be thread safe, at the loss of, you know, having locks, which can defeat the purpose of being multi-threaded if you're just locking all the time on like contended like data access. So I don't know. My thread library doesn't actually work on Linux either right now. My mutexes are broken. So I kind of have a to-do where I have to go back and fix that. I need to get better at multi-threading in general. It's kind of a yeah, I don't have a great multi-threading intuition. Obviously, I know the basics of it. But I need to, I really just need to spend more time and actually like practice writing multi-threaded code. Especially once I'm starting to get deeper into this graphics code. I'm gonna want a lot of this stuff to be thread safe because, well, in the real engines, a lot of the graphics work is actually done like in parallel, in terms of like building your command buffers and stuff, and like, you know, just traversing your scene, because that's like a lot of easily parallelizable work. Okay, what am I doing? I'm just like lost my train of thought. What did I just do? Yeah, it doesn't like this. Conversion from I to int. What? Is this fake? Also, why am I using GCC? Is this a real error? Is this a warning? What? That's so funny. I was literally just doing this earlier. Here, let me cast this. Or let me see, shader type. Here we go. Now it'll work. Yeah, I used to work at Activision doing graphics work, and their renderers pretty crazy the way they build their scene graph or render graph. Thankfully, I didn't have to write any of that code like myself, so I didn't like develop the deep intuition that I guess you would. What is happening here? What is it mad about? Unresolved symbol. Oh, I just didn't implement this. Output generated. Where are we? Shaders. Did I not implement this function? Did I not stub it in? Am I still using HLSL? Yeah, I am. Yeah, that explains it. Yeah, I have a job. That's why I only stream on the weekend. I guess I did Friday too. Yeah, I have a full-time job doing programming. Okay, so it doesn't like stage block main stage. What is it? Oh, I didn't copy this other function. Block main, where is it? Yeah, it is. So I don't have this implemented either. Ay, how many times do I call this? Okay, Okay. I need to change these too. I thought I deleted the in stuff. So we need to do that, delete this, and then what does this look like? So you have a vertex input where you have, I don't want the one with the buffer though, I just want this one. So I need this. So it's just stage in. Oops, don't need metal open or Mac open. So it's just the name of your type, space in, space stage in. And then, yeah, we'll need that other function. We'll need this function soon. And then we also need the type, because it needs to know what this is. Like main type is vertex. And what else were there? Fragment? Does it call it fragment or pixel? All right, let's see. Where's an example of a fragment shader? Here we go. No, that's not it. Here we go. Here's a full shader, I think. Render pixel, they call it pixel. Yeah, fragment, and then they call it pixel. I love it. So fragment is the keyword for this. And I will just assume that this is compute, because that seems logical to me. And we have that. So if we recompile this, rebuild, generate shaders, metal, we are missing the vertex one. Oh no, here we go. Yeah, there we go. We're getting closer. We're starting to look like metal. Now we need the whole list of parameters that metal expects. So these are our uniforms, our textures, well, they're read by me while I'm debugging, so that's why. But yeah, you do bring up a good point. I would argue I'm not being too nice about the formatting. Like if we look at the globe project and like look at the atmosphere shader, like this is not too human readable. Like I'm not formatting my floats. I'm not caring too much about new lines. But it's read by me, so I do care. Oh, and also, my compiler doesn't do error checking beyond the most basic, like, does this meet the expectations of, like, the grammar of the language, right? But I don't actually check the validity of things, like, if your function is returning a float, but you return, like, a texture or something, my language is just going to output the tokens. Like, it's going to generate code assuming that you were correct. Because ultimately, the actual GLSL, HLSL metal compiler is going to run on the code I output. And they'll catch the actual, like, logical errors. In a debug build, I have access to, like, the actual text file of the shader code. So I will output that in the console, like, where the error happened. And it's nice to have that as somewhat human readable, because otherwise it's just like, what is this? What is it mad about? You just don't know. So that's the reasoning for that. So I need to implement these functions, but these need to be something else, because this is more than just semantics at this point. Because we need to do textures, buffers, and then system value semantics. Probably in this order. Actually, I'll do them in this order. Because this is the order that I have for my shader language. This gets a little complicated because the textures need to be included in this list. I'm gonna new line here as well. And then actually I'll new line on the next token. So I need a new type of output here. How do I want to do this? I'm going to do something kind of temporary, kind of gross for a little bit here. So I'm going to just do like static string. So these are like my entry parameters. And then we also have a string that will contain our context parameters. And these are different, two different lists, because they are formatted differently, but they will be one-to-one with each other in theory. So as we parse, I need to also not have a comma here. So as we parse these structures, like if we have a uniform buffer, a constant buffer, or a mutable buffer, these are no longer global namespace, so I need to pass these in. So that's not true. Let me think. Basically what I need to do, if anyone's not following, which is probably likely. So like my vertex, let's go to the fragment shader because I have boilerplate for this, and I'll take this off. So like this is what a real shader looks like in metal. You just have this huge parameter list for your main, your entry point. And like you have your fragment input, and then you have, you know, here's your global like here's your sampler. I guess you would have a sampler per texture. But you have like a sampler, you have your textures, You have your constant buffers. This is like the uniforms. And then you have your system value semantics in like HLSL. So that's, you know, the primitive ID, the vertex ID if you're in the vertex shader. You have like the front facing flag. And those are kind of just like given to you by the pipeline. Hey, how's it going? Hello on both. Sorry, I did not say hello back, I don't think. So yeah, I basically need to convert this into this little context variable that or context structure that I'm gonna create and then pass to all my functions. So yeah, I'm gonna generate this as a string, the input to this context creation, because this will change depending on what you have actually defined for your shader. And there's slight overhead in doing this, but I think the compiler will optimize that out probably. And then the fragment output is also one of these, but I'm also generating this list beyond the input, because this is what actually is, well, actually this is what would be variable here. It would be this order. So it should look like this. But I need to generate this as a string so that I can append it once I actually reach the entry point. And then this needs to be a string too, I guess. So maybe I should put like another string. I need a few strings here. So I need a static string context members. I'll say like context constructor, context members. Then I'll use that later. And then all of these need to get cleared once we start generating the stage. So like reset globals. Dot clear. So we know that we start with a fresh slate every time we start generating a shader stage, which is certainly what we want. And then when we come through here, well, I guess, let me think. Some of these will have some by default, so I'll need to do some stuff in here. To do, this will have like the SV semantics for each stage. And then as I parse the structures, I need to build these. So what is this? Yeah, so I think I need to just add some stuff here to the bottom. I don't have to name this comment yet, I'll deal with that later. So basically we have another switch statement, because these will, write different stuff depending on what they are. So like if we are a texture, I guess, or wait, textures aren't even in this list, are they? Yeah, maybe this isn't the right place to put this. Here, let's do this part first. Actually, I can just do this as an if. There's only 3 of these. So the vertex stage has some stuff. Fragment stage has its own stuff. I have both implemented. So I have a really small quaternion library, and I just recently used those for doing mouse look in my little globe demo. Maybe I can show that off. I don't know if this is gonna compile. Let me see if this compiles first, because I was proud of that I got this to work. Yeah, okay, here we go. Let me just flip this off really quickly. And then I go to my globe. Yeah, so for the mouse look here, in order to do mouse look, where you can actually like pitch the camera and like still have, you know, the mouse up, look up, left, right, looks left and right. You basically need quaternions for this, is what I determined, because I couldn't get it to work for like the life of me using Euler, like a rotation matrix. I think I have, yeah. I still don't fully understand them, to be honest. I kind of just like stole the code from online and made it work with my vector types. And I've like looked at the little diagram, you know, the classic quaternion diagram, which makes like no sense. But yeah, this is cool because you can actually like pitch the camera around and, you know, get close to stuff. Yeah, you can use it if your camera doesn't have roll, because like the typical, you know, FPS camera, you have the gimbal lock on one axis, and that axis is conveniently like straight down and straight up usually. It's like along your up vector for like your world space, I guess. But yeah, the problem I was having is that like when you rotate the camera, when you roll the camera, it's like your up vector changes depending on, you know, the roll. And then you actually start experiencing the problems with the gimbal lock. It's no longer straight up anymore. It's like it could be to the left, and then you get like the weird math that happens over here. But quaternions aren't perfect either, I noticed. So like if you look at the globe here, like look at the orientation of like South America. It's like, you know, north-south right now. If I move my camera in a circle, you can see it induces a roll on my camera. And I was like really beating my head against the wall trying to figure out why the quaternions were like inducing this roll when I moved the camera around. And then I did some like sanity checking then. I went to Google Earth and then also that Space Engine game, if you guys have ever seen that. Because they also have a camera that works like this. And they have the same exact phenomenon. So I think this is just like a property of using quaternions for a mouse look camera, is that you actually get this roll. And the way to fix it is you have to like manually adjust for the roll yourself. Like you can like re-roll back. Yeah, I have very simple like projects, so I was really only using it for the, like in this other project, in the little 3D demo thing I have, my little test bed for 3D graphics. The camera in this thing uses just Euler rotation matrix, because it's just a simple case where you have like a constant, there's no roll in this, so it works fine here. And I don't have physics, like I don't have like rigid body physics or anything. I'm getting blinded by the sun poking through my blinds here. I don't have rigid body physics implemented, or like physics in general. So obviously that's kind of a case you'd use quaternions more for resolving that sort of stuff. Okay, so back to the shader. That was a fun little diversion. Back to build graphics. Flip this back on, because we are making progress. Okay, so what is the list of semantics in HLSL or GLSL? So in HLSL, I have like this function. So these are like all my semantics I care about. And I'm just gonna put these up here in metal. Could have just copy and pasted that. So I basically need all of these in, so I'm gonna put context members dot append. I'll go comment. Actually, I won't comment these because it's obvious by reading it what it is. So you have a primitive ID, which is what, an int, uint, primitive ID, new line, tab. All right, and then we have the, I guess the entry parameters is just, what was that from my little test shader? It's these. So we have a uint primitive ID, primitive, and the constructor, we'll just take that in. I think advice, that's a great question. I guess just start small, right? It's like you don't need to go in making like this big project right from the get-go. Because like for me, this wasn't the first engine I wrote. This is actually like my, I guess my second one or my third, you could say. So like I had, prior to this project, like the actual Manta engine thing where I started to make it more general purpose, I had a separate game I was working on that was just in C++, also with its own engine. But the engine was in the... Yeah, thanks. I'm glad you like it. But yeah, I had a separate game that had its own engine, but like the engine was the game, right? Because like I was just interested in actually just like writing this stuff kind of from scratch. But then I realized the further I got into that, the more I would like a more general purpose version of it. But like creating the first one, like informed a lot of, you know, the things I need for a general purpose one. It's like by doing it in like a sort of rough draft first stage, I could better see like, you know, the actual requirements of a game engine. So like I didn't go into it like with some grand plan. I'm just kind of winging it, to be honest. But I think that's fine. So if like, I don't know, that's my advice, is like don't be afraid to just like start writing stuff. And like I refactor stuff all the time. So like I know some people get kind of afraid of changing code once they write it, especially if you put a lot of time into like what you've written. But like if you get over that fear, it's like so much more fun because you can just change stuff if you don't like the way it is. And that's definitely, at least for me, that was something I had to actually kind of force myself to do. Okay, so we need to take this thing in as a parameter. All right. Then we do the same for the is front face. That is a uint, I guess. I'm surprised it's not a Boolean. Where is this front facing? Yeah, that too. Yeah, if you're using version control, which you should be, like I commit to Git all the time. So like you can just see all the, like I just spam commits. It's also because I work on a couple computers because I have the cross-platform aspect of this. But like the engine I have on the GitHub is like every so often I'll just kind of take, you know, my current state of my working, like my, you know, my working repository and polish it up to like the main one. Because like if you see some of the stuff I write in this one, it's kind of shocking. Okay, so is front face, is front face, is front face. There's probably a cleaner way of doing this, but like I said, I don't really care that deeply right now. Okay, so take that, that. Yeah, because now what I can do with this string, when I'm generating the entry point, where is it? Pipeline. Here, see now, at this point, we can append these. And then the final closing parentheses. And I'm gonna go to the main project, output, generated assets. So in theory for the fragment, whoa, what's going on down here? Yeah, here we go. Sweet. Favorite graphics library. Depends what you mean by that. Like favorite API. I really like DirectX, but I'm biased because that's what I've worked the most with DirectX. But I'm a big fan of DirectX. Actual library, I don't know. I don't use any of them. I haven't used any like the mainstream ones. So I'm ignorant. I'm ignorant on that question. Okay, so we have yeah, well, I've used SDL a little bit. Like, I haven't used the actual graphics side of it though. Like, I've done sort of like small projects where I use SDL for like getting input and stuff and handling the window, but I usually just write my own graphics code because I enjoy writing the graphics code. So that's usually what I do. So is this actually a uint? Certainly not, right? Front facing. Oh, here we go. Here's all of our sample ID. Oh, you can get these too? Sample ID, really? Wow. That's cool. Yeah, this is a Boolean. So this should not be uint. Okay, so what's the equivalent of vertex ID? It's probably just vertex ID. Yeah, of course it is. An unsigned int. VID. And then we have, I assume it's just instance ID, if it's logical. Or not. Yeah, here we go. Oh, here's the list. So we have, is uint the type for declaring base instance needs to be uint or u short? Is u short? Yeah, that's a good point. OpenGL is nice because it's like fully cross-platform too. It's like Vulkan would be great for that, but fortunately Mac doesn't support Vulkan natively. But at least it supports OpenGL up to a certain point, at least, like up to 4.1, so gets you most of the way there. instance ID. Oh, it's a uint. Base instance. Oh, here we go. Here's a list. So base instance. Base vertex. Yeah. Yeah, Metal or a Mac deprecated OpenGL after 4.1 because they want you to use Metal. And it's really annoying because like all the cool stuff, the modern cool stuff came in 4.3. It's like you had like compute shaders came in 4.3. Maybe I don't remember when like the multi-draw indirect, like the indirect draw calls. I don't remember when those came, but I think that's either 4.3 or 4.5. And yeah, bindless textures as well came later, which is unfortunate. So this is actually the main motivation to do Metal right now, is because I want support for like compute shaders across the board. So I can't rely on OpenGL anymore because of the fact that Mac doesn't like OpenGL. Yeah. I agree with that. Okay, so compute stage, dispatch, thread ID. What would this be? Group ID maybe? Oh, wow. Okay. Thread position in grid. Is this your group ID? In thread group. So what are these? I need to get these right. So what's the equivalent? We have like, you have SIMD as well. Wow, this is crazy. What's the Metal equivalent of these? Let me just look these up. No, not that. I'll output this. Oh, this is a good resource. Here we go. Here's the same shader in Metal. Oh, this is actually awesome. Vertex instance. Why is that? You have to wait a day. I'm not seeing too much rendering at the moment because I'm doing just like code generation. Okay, where were we? This isn't the compute. Oh, here we go. Here's a computer. Yeah, here we go. Group thread. This is what I want. This is what I'm after. This is the scripture right here. I'm gonna star this. This is useful. A review of shader languages. Okay. So dispatch thread ID is thread position in group. Dispatch thread ID U3. Thread group ID is this one. Dispatch thread ID. I want these to be the match. So we did this one. Thread group thread ID. So this one. Group ID is that. This should be U3. And I lost my tab, of course I did. uint. What is going on here? That's why you don't copy and paste. Like messing up my crazy formatting. T, okay. U3, U3. This is actually U3. Oh yeah, yeah, that makes sense. Yeah, rendering's fun. Yeah, because you can see immediate results. All right, so thread group, group index, group index, group index, uint, uint. Okay, I think this is all of them. Let me just verify. So what's the order here? So we did thread group, dispatch, 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 uint, uint, thread group ID, uint, uint. This is uint right here. See, would have missed that. Thread group, uint as well. All right, that looks good to me. Yeah, you share links. It should be allowed. I didn't explicitly not allow it, at least. Okay, so if I recompile this, we should see all of this fun stuff in the output shader now, hopefully. So vertex has vertex ID and instance ID. And fragment has primitive. And I'm not generating an entry point for the compute, but I can add one to the function really quickly. Where's my shader? Where am I? Do 1, 2, 3 just to verify that's working. Oh, it's not during. Oh, I didn't do that for the main, for the compute yet. All right, out of here. Component, are you talking like entity components? Is that what you're asking? Okay, so you have to fix this really quickly. Yeah, so these don't actually have any parameters. Yeah, so I'm actually not using entity component system. I do have a system for entities though. It's kind of interesting. I don't know if my little project where I demonstrate it will actually work though. Systems. This probably won't compile. I basically have an entity system that it's like inheritance based. So it's like the classic, you know, object oriented entity system. But I have some rules on it, so it's single inheritance, and the I am being careful with how the memory is allocated for the entities. So like, I don't know, it's kind of hard to describe without just showing how it works. But yeah, it's inheritance based. So like you have like an object type. I call them objects in my engine. So like you define, let me go to an example. I can grab one really quickly. Objects. So here's like the human, the little the guy you can control in my other game. Maybe I can pull this one up. This one should compile. But I need to turn the graphics back on. This should run, I think. Yeah, so this is this project. So like, obviously the character is an object, and you can throw these little grenades. So like, I have a system to do this. I'll look at the grenade actually, because it's easier to, it's less code. So here's like the object file for the grenade. And it's kind of interesting because I do something similar to what I do with the shader language, though not as intense. But I have this like .object file that sort of lets you kind of script these in quotes, because it's not really scripting. But it's like you basically describe the layout of the actual class that gets generated. So like you have the name and like, does this inherit from anything? So like the grenade is an entity, and the game obviously controls what entities like are in the world. And then there's like, you have like some of the basic functions that objects can have. So you have like what is its constructor? You know, what is its update function? And like every object can have an update function. And then you can have custom functions as well on these. Like I think the human might have some custom ones. Yeah, like the human has its own draw function. But the build system basically parses those into just like C++ classes. So I have like these generated object. So if I go to like the grenade, object grenade. Yeah, here's the grenade object. So this is like its generated class. And it gets complicated because like, I don't know, I'm generating these classes. Long story short, this is optimized so that the memory for each object like type group is like allocated in these like consecutive, you know, linear blocks of memory. So like when you're iterating over a bunch of objects like of a specific type, you're just like shooting through this, you know, this single block of memory. So it's like really friendly for cache there. But yeah, you're kind of still stuck with this sort of inheritance-based thing. If that makes any sense. I just kind of rambled for a bit. All right, back to shaders. Okay, so I need to add, let's see. Oh, and the other cool thing is that the object system, I built in support for serialization of objects, because I figured like, so in that game I just showed, the little Terraria clone, obviously if I keep developing that into a real game, like you might update the game later on and add new types of objects, or like change the base properties of the existing objects. So it would be nice to be able to like, when you actually generate a save file and like save the world, right? You want to generate a save file. It'd be nice if a lot of that serialization stuff could be automated. So the object system has, it does parse some of that information to help with serialization, which is neat. Okay, this is not formatted correctly because I have a comma here. So the first one for compute does not need a comma, which would be, I guess this one. Where is it? Here. Doesn't need a new line either, or tab. Yeah, serialization is a pain in the ass. And that's useful for networking too, 'cause like obviously you want to send like serialized data over the network. Because if you have cross-platform networking, right? Like you don't actually guarantee that the the layout of the bits is exactly the same between two like or like two architectures. Now that's really not a problem in most cases, like especially in modern day. But like it's possible, you know, like you have like little endian and like big endian. I think I'm saying that right. Endian. I don't remember the right word for that. But where it's like, is your least significant bit like the large bit or the small bit? You know, which way does it? You know, like that actually can matter if you're sending, you know, just raw data over the network. Okay, so what's the next step here? I need to do this context creation thing. So what do I have? So generate structure, generate function declaration. So yeah, every time I call a function, I pass in this context thing. So let me make sure that worked. Yeah, here we go. We have access to this context through every function call, but we're not actually passing it to the function calls too. So we need to pass it. And I do that in DirectX. Where do I do this? So generate function call parameters, I guess. Intrinsics. Just copy both of these because we might need them. Oh man, what a function. Okay. This is quite the project. Yeah, you need reflection. It's good to have at least. Okay, so parameters, so we pass in this, we give it the context. All right. And then I think that's all we need to do actually. These need to be passed as well. So we don't want to skip these. I don't think. Yeah, we can cut that out. And then function call, this should be fine. Does not know what get param is. It's because these are HLSL. Oh, I errored. What? How do I not have a get param? All right, here we go. So we're getting closer. So like this function call is now automatically, I inserted this context passing thing here. And then now this shader or this function has access to the context. And then like this global sampler thing is going to be on the context is what I need to change next. But I still need to actually generate this in the main function. So let's do that. So the entry point needs, let's see. I need to do this in both the main and the pipeline. So I need to override the statement block as well. Oh, I guess I already grabbed that, didn't I? Did I already have this function? Oh, I already had this function. Yeah, I guess this is why I cached that before. So now we'll just indent everything in a scope, and we will return whoa, what is happening? I did new line here, first of all. And these I need to constructor. Oops. What is happening? Here, I won't add indentation. I do have my own memory like wrapper. I just use malloc right now though. Why doesn't that have indentation? I'm caring so much about the way this is formatted for no reason whatsoever. Sub. I think this is it. I think we're getting there. And I need one of these. I do have like, yeah, I do do some stuff with memory actually. Now that you mentioned that, I just did some work on that this week. Yeah, here we go. This looks much better. Yeah, so now like the fragment or the vertex shader, it's like you create this context thing. I guess I don't need an equal sign here. And then we pass this around to everybody who calls it. It's like now we have this little neat object. Yeah, so I don't do too much fancy with that really. Like with the graphics stuff, if I just did a big refactor to the graphics this past week. So I'm like, obviously I'm continuing on that. But I did do some stuff where, let me go into the project, runtime, main. So basically what I did, I can zoom out just a little bit, is so like previous to this week, before this week, my graphics like API was very like fixed function kind of themed, where like there's just this global state and you kind of push to the global state with like, hey, bind this shader, hey, set this texture, set this render target, kind of like, you know, like old school OpenGL programming. But now that I want to do Metal in like DirectX 12 and Vulkan, I kind of realized that it's kind of stupid to do that, because the way those APIs actually work under the hood, or I guess just how they work in general, is you have like the pipeline state objects, you know, and like the command lists. You like submit command buffers. So I did a big refactor of my API to better align with that. So I added like the concept of a render pass, which like you bind targets to, or where is it? It's not here. Here we go. You like bind targets to it. And you have like render commands. So these are like your pipeline states. And then you have a list of, you know, work that's associated with a command. And where am I? Am I even in the right project? Yeah, it's like, and I added this system with the render commands where you can basically create these commands and then add work that's like deferred. So like I can then submit this command to a render pass, or a scene graph, a render graph, and then like do stuff with the commands before I actually like commit the work to be, you know, executed by the graphics card. So I needed a way of basically having these functions that you sort of define, you know, like your actual draw calls, be stored in a deferred way on these render commands. So what you really need is like, you need to store a function pointer, obviously, that's easy, it's just a pointer. But the commands also might take inputs, right? Like there is more context to a draw call than just like, hey, these are some like, you know, draw calls that have baked in parameters. Like there's actual like state here that needs to be stored as well. So the commands needed a way of storing the state, so it can be retrieved later when you actually go to execute that function. So I implemented a little stack to handle that, and it's like really trivial, right? It's just basically and this would be nice for an arena because you don't have to like pay the cost for like realloc as your stack would get larger. Right now I have it implemented as just, you know, this thing that if it exceeds the capacity of its like current allocated block of memory, it just reallocs until it's big enough again. So like this is what you would use the arena for, is replacing this. But I do account for the alignment of the actual, you know, members that are going into this thing. Because obviously if you're reading that back later, you want your types to be aligned, right? With the correct alignment requirements. Otherwise you'll pay the cost of like, you know, either either like the CPU will need to, you know, like say you wrote like a double, but you weren't aligned to the requirements of a double. It's like the modern CPU can handle that, right? But it takes more instructions to convert an unaligned double back to like an aligned double, because it has to kind of like, you know, individually like re-stitch it together, but like byte by byte if it's not aligned correctly. So yeah, that stuff I'm accounting for all over the place. But the actual pointer that my malloc is returning, I'm not doing anything. Like I'm just literally calling malloc. But I use my little function, my little wrapper around malloc. So if I ever want to change that, it's easy to just like go in here and change it. And now it's like, hey, now my alloc call will always be like aligned to some boundary. So I have thought about that. I just haven't done it yet. Okay, so back to shader stuff. But yeah, like, I guess on that point, I'm really careful about how I allocate memory in the engine, because, and this is where I diverge from like the modern C++ writer, I think, is like I have all my own container implementations for like list and buffer and, you know, hash map and all that. Because I like having the full control over how these things actually allocate memory and, you know, how they work. And of course, like I know you can write a custom allocator for the standard, like the STD equivalents. Like they obviously let you template in your own allocators and whatnot. But I just thought it'd be easier to write my own because they're not that complicated, really. But my engine doesn't really do much runtime memory allocation. It's all like pre-allocated blocks of memory. And only in certain situations like this, where like a frame might have an unpredictable load of work, do I sort of allow reallocs to happen. But even with this stack thing I just described, I just have like a static stack like on the renderer, you know? So I reset the stack pointer every frame, but I don't like reallocate the memory, right? So it basically will grow up to like the maximum size that, you know, some frame has ever wanted. And then if like the next frame is less work, now you just have this big block of memory. I'm not resetting the reallocation each frame. So it's kind of like lazy initializes how much memory it needs based on, you know, the incoming work. But you only pay for these malloc and reallocs like the first times that they happen. So I think that's fine. And then it would be trivial to like track how much memory is allocated by that system. And like you could shrink it if it ever exceeds like some limit that you have. If you have like some tight budget, maybe you can monitor it afterwards. But that's my general philosophy for like memory allocations. And like the object system that I talked about earlier, the entity system, it kind of works in a similar way where like all of the memory for that thing is pretty much pre-allocated at engine startup. So like the per object creation or deletion is never allocating memory. It's always just like using an existing block. So it's kind of, it's just efficient in that way. Because yeah, you pay a lot of cost if you're like allocating memory all the time. Okay, so context. I need to get the output in here as well. So I need to capture that from up here somewhere. It's probably what this thing was. Why do I call this instance output? Hey, how's it going? Ninja. It's like your name's Ninja. I need to capture this thing, the out variable. I'm just going to store this as some local some global thing. So we have we'll just clear this. Clear. This is messy, but it doesn't need to be clean because it's like a shader compiler that runs once. Yeah, see, like, yeah, with what you're saying right there, like what you could do, which is like what I do for my per frame render command buffer thing, stack, is that you just keep a pointer to that block of memory, like a scratch buffer, I guess is like what these are called usually. Like you just have this scratch buffer that you malloc, but instead of reallocating it every time you need it, you can just keep it allocated and then grow it when it needs to grow. So like you allocate this thing at startup and then just track its size, so you have like, you just know that this buffer exists and it's ready to go whenever you actually need to use it, like for like the HTTPS request or the curl request, I guess. Because then it's like, and you only reallocate it if you need more data than it already is in size. Okay, so we need this member variable type, out type name dot let's call this out. Okay. So then we need to have this sort up here too. I'll call this entry output variable. That's what I would call this thing. And then in main, we have this twice. So it's like if this thing is not empty, we will append it. So now we have the output variable for the stage, hopefully. Where am I? I am in the wrong project. Oh, I didn't turn this back on. Wait, yeah, I did. Wrong project. I have like too many folders here. I just get lost all the time. Okay, so we should have, here we go. The fragment output is this thing. So you have to specify it. Okay, let me see. Yeah, you're right. Writing the spaghetti code, ghetto code. Yeah. Yeah, there's a lot of ways you can solve that problem too. Okay, so return. Now these don't always return as well. Like this should have been cleared, but I guess it wasn't because I didn't do that correctly. Put that up top, up here. In the generate stage. And then last but not least, we need to cover this, wrap that. Whoa, there's a lot of code going in the chat here. It's not on my end, it's not formatted very well, so it's kind of hard to read. Yeah, so like what you're doing is basically what you would yeah, you just have a basic realloc going on. So rather than having, I guess what you do is you just store that memory thing, you know, globally, statically, or whatever on whatever context that you're running that code in. Just store it as something that's like persistent throughout, you know, the context of that code. So you're only reallocating when there's like a new need to realloc. Yeah, I'm not familiar with any of that, so I don't know what curl or any of that is. So I don't know, I can't help too much. Okay, so metal output generated shaders. All right, here we go. So does the fragment as an output v out. So I guess I should call this v out maybe. Because that's what it is, v out. Where am I writing that v out? Append. I guess I should make this, what's the name of that thing? Yeah, I know what you're saying makes sense. I follow that. Okay. I'm just spamming static strings at the top of my function. Because who cares anymore? I will just call this return. Because this is really what matters. Whoa. Happened. I am certainly printing the wrong thing. Equals. Yeah, obviously that doesn't make any sense. All right, here we go. Still not the right name though. What? This should just be out type. Should be. What is happening? Out ID. Yeah, here we go. Now our flow is looking a lot better. So we have, let's see. Yeah, so we have the output thing being created, return it if it exists. We have the context being initialized. And we don't actually generate the context yet, so now we need to write that as well. Right before we print the main function, we need to generate the context. So we just output a little structure. And then, what was this thing called? Entry, I don't know, context members. Let me close this. To name this thing. Oh, this gave me an error. Oh, that's not a real error. All right, there we go. We have the context for this thing is generated here, and then we use it. We fill it. And then we pass it to functions, and functions have access to it, except it's not going to work because this thing is not forward declared by the time the functions use it. So we actually need to generate that at the top of the file, it appears. Which actually complicates things a little bit. Yeah, because like this function is there. So it won't know what context is yet because it's down here. This would need to be like It needs to be like right there. All right, I'll worry about that in a little bit though. We need to get the other parameters in here next. So when we parse in the parameters here, so what is this? Function declaration. We need to parse the function. There's like a special parse for the function declaration. So we need generate function declaration. Yeah, we need this for loop here. And that needs to go in here. Where do I generate this? Okay, so where do I do this? I need to look at the code. Wait, that's the only place I do that. No, that's not what I want. So what is first and last? Here we go. Okay. Because what we have right now, what is this? Okay. +2. So skip the input output. Yeah, so yeah, the way the shader language works, what I'm doing right now for context is I have in my, oh jeez, I just get so lost in here. Runtime, here we go. So like in my shader language, I thought I had a bit about how metal works. Clearly not far enough though, because I didn't fully model it after metal, which is kind of unfortunate. I might change that. But you pass, I designed so you also pass things around by function parameters, and the uniforms are like that. So you pass them into the entry point, and then like you pass them around if you want to use them elsewhere, like to this function. So right now I output the input, and then the output becomes like that return value in the main function. But now I need to process these extra uniforms. So that's what this code should do. And here it says skip, but it's actually, if it's not any of these, this is an error case. I'll put it to do error if not. So hey, how's it going? Welcome to the live stream. Okay, so parameter type. It's I'm working on metal right now actually. But I have OpenGL DirectX already working. But I'm working on metal. And then next I'm gonna do Vulkan. But I'm generating shader code right now, actually. Nice. Yeah, I'm saving Vulkan for last, you know, the final boss. Const, these would never be const. Okay, so we append that guy. So what do these look like? So we have like a list of constant uniforms. Are these always constant? I guess if it's a mutable buffer, it's not. Buffer. Okay. So I'm just going to switch on the type here. How was I doing that just before, actually? If parameter type dot token type. Yeah, I was using that interface. Okay. Yeah, I have some experience with Vulkan. Sorry, I'm kind of I'm like in the zone here. I have some experience with Vulkan. I've used it before. I've used it like professionally at work, but I haven't like written like a Vulkan renderer myself from scratch yet. So I'm working my way up, I guess. Well, I'm taking the most meandering route to get there. Okay, so constant. What was this? It needs to be the name and then, okay, a reference or a, yeah, reference. And then, okay, buffer. So we output the type name. Ampersand. Here, I'll put these all in one line. Type name at variable name. And then append space buffer. Okay, so that is the uniforms. Constants are the same way, I believe, because they're basically the same implementation. And then this would be a, I guess, not constant, because it just doesn't have anything. Okay, now we should see these in the output. We don't. List at, what is happening? Oh, I have this code here. No, what? Index greater than current. What's happening? Where? Is it this code? Let me make sure it's this code that's actually failing. It's really annoying to debug my build tool because I don't have the debugger easily attachable for that yet. Okay, which line is failing? Is it output.append type variable? Is it this that's failing? I? It's not the best call stack. Index list at 25 is out of bounds. Fascinating. That's interesting. Type ID, parameter type. No, that's not it. Trial and error until we get this to compile. What am I missing? What am I messing up? So, which line is it? It's that first line. Yeah, it's this line. Really? Aren't I using that right here? Parser dot variables. Oh, I see what's happening. Okay, this should work now. I was reading out of bounds. Okay. Because my +2 is shifting both ends of my loop instead of just the one. Okay, so I should see in the output generated shaders, metal. Yeah, here we go. Kind of. We're not new lining, and the slot is not correct. All right, let's figure this out. So we didn't new line, which I guess we don't have to. Or I will do the new line tab here. New line tab. Okay. Actually, that should be up here. Except this did not work, I don't think. Parameter name, space. Oh, I'm appending this here. This shouldn't be there. Okay, yeah, here we go. Looks pretty good, except for this -1 on the buffer for some reason. Because that works here. Why does that not work here? It's the same uniform. Is that associated with the type? Yeah, how does this work? Where am I storing this? When I generate the structure, I'm getting that from somewhere. Generate structure. Expect. Where is it? Semantic. Oh, that's not it. Where is this? Slot, structure.slot. So this needs to be struct ID. Oh, that's unfortunate. Yeah, I need to store this somewhere. So I don't have access to this actually at this point. Because I store a list of parameters, which are I think the type needs to have a slot on it as well. Yeah, we parse the slot here, and then we grab it here. Okay, this should work. Such a hack job. Okay, let's see. Now that type should be the correct thing. So this should just be fine now. Theory. Yeah, here we go. So as we append buffers to that entry point, we're now getting some valid metal code here, which is exciting. Okay, now the next step is I need to close my blinds. I'm getting blinded by the sun right now. There we go. Okay, so we're not out of the woods yet because we need to add this thing to the list of entry parameters. So for context, constructor. Oh no, this doesn't belong in that. Yeah, I think this is fine actually. This is perfect. Okay, what else? Let me see how metal. Like if you pass these things around as parameters. All right, I'm just gonna do the textures really quickly. Okay, so when we parse, I have a parse texture somewhere, or a generate texture. We need this guy. And we'll steal the one from HLSL, because that's more close to what we want. It's closest to what we want. Okay, so when we see a texture node, we actually don't use it immediately. Unlike HLSL and GLSL. So we actually need to pass this thing to the the entry parameters, to the entry point. So what was this though? It's like texture. What was it? OpenGL. So you pass, these are compute. Oh, where's the fragment shader? What is happening? Okay, so these are texture 2D underscore, or lowercase, it looks like. Yeah, here we go. Here's the big list. Okay. So basically we generate these as our inputs. 3D cube, cube array. Okay. So that is our texture name. And then, so we actually don't write these. Directly. Texture name. And we append the type name. And is that by reference or by copy? Okay. And we append the name of this thing. And we have to append the binding slot. All right. Then we need to add this to the context members.append. Same thing. Missing a semicolon. Yeah, 1 second, I can show you. Yeah, sorry, I'm kind of like not doing a bunch of like code right now, but not doing anything too visual. Yeah, just a second. Okay, I have an extra space. Let me just fix the formatting on this really quickly. So what do I expect here? Oh, I expect a new line to be handled. Oh, I guess I don't need a space there. Okay. Yeah, okay. Yeah, so, sorry, I'm working on some shader code generation right now. it's got this texture thing to work for capturing the, I guess the textures you have defined. Yeah, let me just turn on, let me get the compilation to work again. I always need to flip this flag here. Yeah, I don't have a ton to show off really. I have this little globe demo, which is kind of the go-to. So here's like just a little globe project. I've been working on the rendering a lot lately, so this is kind of a good little example of a renderer with somewhat complicated shaders because the clouds are actually ray marched, so they have like depth to them. If I get too close, the effect kind of breaks down a little bit, but yeah, so this is like the go-to demo example. And that was with DirectX open backend. And then the engine's has support for multiple graphics APIs because it's cross-platform. So this is with OpenGL. So exactly the same, obviously. It should look exactly the same. But it runs OpenGL under the hood now. So here's like, yeah, this is just a little 3D example. And then this is a little 2D example game that I worked on quite a bit earlier in the year. So it has like, it's a Terraria clone basically. But it has some cool stuff. The rendering is a little broken in this project actually, because of the big refactor I just did earlier in the week. But it's kind of neat. I mean, you can use whatever language you want, really. I like C++ just because I'm most familiar with it. And I think it's a good language to do like game engines in. But like all the principles of a game engine, you could basically do in any language you want. What else do I have to show off? It's kind of it. I have this little chess game. I don't know if this will compile. No, it won't. Oh yeah, maybe it will. I have a little chess game, which is fun. Really basic. But the cool thing is I can like make multiple games like really quickly. I have a little 3D example thing. This is my 3D test bed project, so I just kind of throw a bunch of crap in here. Like I can turn on snow. Maybe. Test the snow, maybe. Here we go. Yeah, I can turn on snow. Yeah, the 3D one's cool because last live stream I was working on this. And these little glass panes are actually sorted. Whoa, what's going on? Here we go. Why are my calls looking so crazy? What's happening? Here, let me regenerate this. I think I have some weird state going on here. I don't know. Yeah, exactly. You can use any language you want. And OpenGL is good to start with too, because it's cross-platform, kind of out of the box, because it's widely supported. So, yeah. Okay, so we also need to generate a sampler. So I'm going to just make one of these for now until I support multiple sampler objects. So it will be called global sampler. This is a to-do because I should be supporting a sampler per texture, actually. And then the members is just, what would that be? I don't even know what that means, so probably not. Event buses. I've never used Unreal Engine, so I actually don't know what abstraction they have over handling events. My general philosophy for the game engine is that like that sort of thing would be handled by the game. So like if my game needs an event system, it should be trivial for me to implement an event system like in my game. Because like it's just C++, right? You can just implement that however you would need to implement an event system. That's not something the engine would take care of. At least that's my goal for the engine, is it's like as bare bones as possible while still being like a nice platform to make complex things is my goal. So of course the engine handles like rendering and like window management and input and like handling assets and all of that sort of stuff. Okay, what am I doing? I am in an infinite loop, it appears. What did I do wrong? Because look, I'm stuck here. What did I do wrong? Let's see. Context has sampler. Entry parameters. Entry global sampler. I don't know what I could have possibly done wrong here. Is it this? Does it not like this? No, what'd I do? It's just working. I don't know what I just did, to be honest. What'd I do? Oh, I'm not in the right project. Of course I'm not. That explains it. Okay. Let's turn this back on. Okay, shaders, output. I'm actually making some good progress. This is like almost done, surprisingly. Output generated, shaders, metal. Yeah, here we go. So now we have a global sampler, which is a to-do because it should change. But for now, I'm just going to implement it like this because I haven't made that change in the wider context of the engine yet. And then the context has its sampler. And then it gets past the sampler. And then when I sample textures, I should sample from the context. So I need to do that next. So like my function to sample texture needs to be specific to doing that. Okay, so let's see. I also need to handle the SV things. So we need to generate an SV semantic. GSLL. So we need to generate one of these, which is after the function call. So I'll do these next. Let's take the one from HLSL. Put that in here. So this thing gets it from the context. So if in my shader code I do anything with the vertex ID, which is probably not, like int vertex ID generate that, output generated shaders metal. Here we go. Yeah, so it gets the vertex ID from the context, which is cool. So I need to generate this thing at the top of the file though, which is also kind of annoying. I guess I can just insert it at the end when I'm done. I'm gonna do that. Yeah, because that should work out. Or, let me think. Yeah, because it only has textures and, yeah, okay, that should be fine. Yeah, the problem is, like earlier I said that this context class, or this context struct, this thing needs to like be a global thing at the top of the file, just so like, you know, this function that has it passed to it, you know, this context needs to come before this. And it shouldn't be up to the source shader code to like enforce that. It should just work. So we'll need to like do this at the very end, is insert this into the source code. So I will do that. So like when everything is done, we insert the context. Let's see. So here, where we do this append, generate stage, where is that? Here we go. So we insert basically insert the context. So we need to insert these in reverse order. Actually, I'll just generate this. Yeah, here we go. Now we have this header at the top. The context is like the next thing. So this is like everything down below that ends up in the global state, ends up in this. And then we can read from it as if it's like a global state anywhere in the shader. So now we just need to change the sample function to actually sample the texture in the correct way. I have to look up how that's done in Metal in this reference shader I have. So it's just a call to sample, it looks like. Let me see if there's anything in the docs. Sample. Yeah, cool. This is actually pretty simple. So instead of calling sample, we just call lowercase sample. Is there like a sample level? Oops. Okay, what do we do? Data types, textures, textures. How do you actually sample these things? Texture. Should be samplers is what I'm looking at. Is there like a sample level? I just want like a list of all of these functions. Because I have a bunch of these. It's like sample. Let's leave them as to-dos for now. This needs to be context dot. Oops. Or no, this needs to be context dot. Context dot. This is also context dot. Um, that's a great question. It's a great question. I think it's a good tool if you're careful. It depends how they're using it. Like, I like ChatGPT for like using it like a search engine for finding ideas or like concepts, you know? Like a lot of times it's like I know what I'm looking for, like some programming thing, and it's like I just don't know exactly the terms to search to actually find the precise thing I'm looking for. And like I think ChatGPT is really good for that. It's like good for bouncing ideas off. I don't think it's good if you're using it to like copy and paste code though. Especially if you're not like actually like trying to understand the code that it's giving you as well. I think it can be more harmful than good. Like I find it really useful. But it's also because like I have experience programming, so like I know what the code should look like. If that makes sense. All right, where am I looking? Yeah, here we go. Context dot texture sample. That came from this, which came from this. Yeah, I don't know. it's a tough thing. I think I would have learned a lot faster if ChatGPT existed, like when I was learning the program, because it's like really good as like a, you know, someone. It's like something you can bug questions and it's like won't get annoyed with you. And it's like it's right most of the time if you ask it sort of general things. Okay, what else do I have to do here? I think that's it. Like I pass primitives, uniforms, sampler. I think my metal shader compiler is done. Oh, I need to fix the struct for these. These are always just struct, so yeah. Yeah, sometimes to be honest, sometimes I just said it would be nice if ChatGPT existed when I was learning, but I also feel like it's kind of nice that it didn't exist when I was learning because there was no cheat code to like actually learn stuff. It's a true double-edged sword, isn't it? And people ask me sometimes, like family and stuff, how I feel about AI with taking over, you know, jobs, because there's so much hype around ChatGPT like replacing programmers, and I'm not super convinced of that yet. Like I can see it getting better, like it's because it's definitely improving with each new like version or whatever, but I feel like just the rate of improvement is sort of plateauing, at least from my experience. I don't know if we're just getting like throttled models or something. And I'm not like a huge AI guy, so I'm not on the cutting edge. But I just see the AI get the code wrong a lot. Like it's because I only ask it to code stuff I already like know generally how it should be programmed. So like I can see where it's making like blatant errors. And it's like it just doesn't. It's not precise. That's the problem with AIs. It's just not precise. And now you have these like the models that they do like the reasoning. So like they have they have multiple stages where they try and like reason about like come up with a plan, and then they start to execute the plan. Then they go back and they like reason about the plan that was just generated. So they're like trying to solve that problem by having like that back and forth sort of, I don't know, thing going on. And it's like it is good. It's not bad. Like it's kind of it's incredible that AI can generate like anything at all. It just seems like magic, to be honest. But it's like still a statistical process, right? Like you're never going to get a precise output. You're just going to get closer to being like 100%, right? And the problem with like programming, at least programming complicated things, is like as your project gets larger, like you need the precision for every step to be like correct. Otherwise, it could come tumbling down. And then the problem is like if the whole software was written by AI, and then like a problem eventually happens because it's not perfect. It's like, well, who's going to be able to go in and reason about how to fix it? I don't know. I guess we'll just see what happens. The future is unfolding, so I guess we'll see. I'm not like immediately worried though. I think it's just another tool that's like very useful, but not going to take my job at least. Okay, let's see. What do I have to do here? So we have a sample. We do that. I guess the next step is to just try and compile this stuff and see if it works. Yeah, we can hook up the compiler now. Because I think this is all in now. We have the input, output, our parameters. We have the main. We have our entry points. We have parameters being passed to the entry point. Uniforms being passed around. Basic logical structure. I need to fix the compute stage actually. Fix that really quick. I guess this should be part of. I guess this doesn't need to be here. This can just be. All right, but I will be back in a second. Let me go get a drink. All right, I am back. Actually gonna snack on this bar real quick, so I'm gonna mute myself so you don't hear me munching. Man, Twitch has to get a handle on these view bot spam. It's like every stream, every couple hours I get a buy viewers. Why would I want to buy viewers? Such a crazy concept. Does that actually help anything, buying viewers? All right, let's do a little clean, a little build. Oh yeah, this isn't gonna work. I need to turn off this. We're gonna actually get the compiler hooked up now, the actual shader, the metal shader compiler, so we can start to see if our code is any good. Because if we make any syntax errors or anything, it will certainly pick it up. All right, where is the if one? Let's turn this off. Oh, what's happening? Uh-oh. Set shader. What? Oh yeah, I wrapped that in a render command. Well, that shouldn't have done anything. What was going on? How do I go here? Go. Ah. I hate programming on Mac. Mac is such a wonky interface. Such a wonky interface. All right. This was just compiling earlier, so I don't know what's going on. Let's see. Let's find out. Metal. Command. Assert shader.resource is not equal to null pointer. Okay, that makes sense to me, I guess. Let's just implement the shader stuff. So source, Manta, backend, GFX, metal. So we need shader init. Here's our shader init. And I'm just gonna copy whatever DirectX is doing here. Yeah, here we go. Bunch of assertion stuff. Copy that. Paste that. But we have to delete pretty much all of this, except the profiling stuff. So maybe I can make this a bit bigger for the stream. Okay, so we have the shader ID, so we need to actually put this guy. resource. What does a shader resource have on it? It has all of this stuff. And then I need to open up the other project I have. So this here is my metal testbed project, which is just a triangle or a square that bounces up and down. This is with metal, which is really exciting. So we need to look at the renderer where we initialize the shaders. Shader types. This is crazy. Oh, wow. Is this actually, I need to do this for text array? Okay, whatever. Fragment vertex. So we need render. I'm just going to copy this. We will clean this up in a little bit. So we create a shader library. Is this just like a program? What is this MTL lib thing? I don't remember doing this. Let's see. Yeah, this might be something I have to look up how to do at runtime. Because this is not something I know how to do just off the top of my head. Go to the AI overlords and ask them, how do you do this? Yeah, so this is something you need to do ahead of time, at like build time. Yeah, so I will I will optimize this later, so I'm not compiling shaders at build time or at runtime. At least I'm not compiling them from raw text. But for now, I'm just going to do it like this, because that gets me off the ground as fast as possible. Yeah, this is what I'm after. So we create this shader library thing. I will not make this static. Let's have a new one of these. Okay, this should just compile off the bat. It's not gonna actually do anything though. But now I just need to fix this because this comes from, where should I actually get the source code for this? It's like the fragment one. Oops, I keep getting these flipped around. Vertex fragment. So we need this as well. All right, now let's watch this not work, because it never works on the first try. All right, we have errors. Some nice errors. Warning, error. Cannot initialize a parameter of type const char of const void. Oh, this should be const char. Failed assertion. Source must not be nil. All right, let's just print the source as well, just to make sure this is actually. To make sure this is actually some sane value. What are notes? All right, yeah, this is certainly. Oh yeah, it's just blowing past the buffer, of course. Okay, come on, why is it not pasting? Copy. Paste. Source must not be nil. Specify nil terminate string. Code vertex, code length. Yeah, we'll just do that. All right, it actually made it pretty far. Did it fail to compile the fragment shader? No, the vertex shader. Yeah, the question is why? Come on. That didn't even give me what I wanted. Stop. All right. Oh, I'm not writing that. Here we go. Here's some actual useful information. Error. Position attribute takes no arguments. Okay. It's good to know. Invalid return type. For vertex function. What do you mean invalid return type? What's wrong with that? No output declaration with attribute position. Name V pipeline. Okay, we have some problems. Let's hit these one by one though. The position one's easy to fix. Let's see. So let's go to build, shaders, .metal. So this is just position, I guess. Yeah, okay, that solved that problem. And then it's just mad about this matrix MVP thing. Pipeline uniforms, which is from V pipeline in uniforms. Oh, I have this whole thing printed here. So I need to change this T pipeline. Yeah, these are both not real issues. It's just me not doing this correctly. Hey, how's it going? Welcome to the live stream. Okay, so what is it doing here? So let's see. Generate structure. Yeah, things are going good. Other than these compiler errors. Yo, what's up? At first I thought you were saying C++, yo. But I realized that's part of your name. It's good. It's a crazy name. All right, what's happening here? We got some crazy substitution. This, yeah, we don't need this. This is not necessary anymore. All right, here we go. Here we go. That's an insane name. It really is. Failed to compile vertex shader. Out dot. Oh yeah, I don't have a mul. So does metal not have a mul intrinsic? It must use the override for the asterisk, which we need to steal from GLSL. So mul is just this. Need this guy. Yeah, I'm also a C++ guy. So we're in the right spot. Okay, failed to compile. All right, we've compiled the vertex shader successfully. Which is exciting. We're making some good progress here. All right, but we need to let's think for a second. What's next? Fragment shader. What is happening? I can't think. Yeah, back to back end metal. I'm gonna pull this into a little lambda. That will take a NS error, return const char pointer. And we just do this in there instead. Actually, this might not work because it's probably going to like fall off the stack as soon as this function ends, but we will see what happens. Let me invoke an error on purpose, just so I can test that this works. This should certainly be an error. Oh no, it's catching it from my own. Oh, you know what, I'll just do like... Let me just reverse what I just did. I knew this was a valid error. I do, yeah, he's funny. Yeah, I watch his stream sometimes. I haven't seen him in a while, but yeah, he's funny. He's a funny guy. Okay, what's going on? I don't have the same energy as him, I think. So... Okay, here we go. Oh, it did work. Great. Cool. Wasn't sure if that error checking would work. So I can copy this. Failed to, I guess, get vertex shader. I have to turn off this debug message error thing. It's so annoying. All right. I know. All right, so we failed to compile the fragment shader. We don't have a template for texture 2D. Where was I trying to use that? Texture, oh, up here. I didn't lowercase that. Interesting. This should certainly be lowercase t. If that's the only error, then we're golden. Undeclared identifier discard. Do you just return when you discard in metal? What's this problem too? Future requirement is color texture channel float invalid channel texture text T. So what's the matter? Texture 2D float 4. How is that not valid? What? Is that real? Let's see. How does it know how many yeah. So how does it know how many channels there are? Does it not matter? Maybe it's just always assumed that you have a four float channel. So where do I generate that? See, there's just all these little quirks with how each of these shader languages does things. Okay, so we have this problem. So we're generating this type name. We need to like get the base type. Channel type, I guess you would call it, is null for now. Well, we'll just assume float, I guess, since it won't error if it's a float. And then we need to switch on the type ID, or the what is it? Primitive. Yeah, it's it's pretty much it's very similar, except mine, this is simpler than a real compiler, because usually if you're generating a real compiler that's like generating like actual output that runs, you would have like error checking built in for like the validity of, you know, the code that you're writing. Since mine is more of a translator than a compiler, I don't do as thorough error checking. But I still build the syntax tree, and I still have like, you know, a high level representation of the program in like a tree, like a graph. And then I traverse that to generate this output code. And then depending on, like, if I'm in Metal, I'm obviously doing additional logic to figure out how did these concepts translate to like valid Metal shader code. So my output is just text. Yeah, because if you're writing a real compiler, you would generate, like assembly instructions. And you would want to like verify that those like instructions are actually valid operations. So you check for errors. Like, yeah, just more thoroughly. So yeah, I don't do that, which is nice because it makes the code simpler for like my actual compiler. I never know what to call it, because it's like it is a compiler in that it's, you know, doing pretty much all the stuff a compiler does, but it's just generating like text file in a different shader language. So it's like a translator, or a transpiler, I've heard people call it. Okay, so now we have the channel type. So this is actually what I think Metal expects. So I think I did variable name, type name, I need to replace with this. And then let's rebuild. It's mostly a time thing. I just don't have the time. Because I have a full-time job that I spend most of the week doing, and then the weekends it's like... Yeah, I've thought about it. I need to get better at communicating ideas, though, in like a teaching fashion. Okay, so use of discard. So the error with the texture thing is fixed. Yeah, here we go. We're getting the texture 2D float. Now I just need to fix this discard problem. So does metal not have a discard keyword? Whole words. I don't think metal has a discard function. The metal function terminates a fragment. Oh, so you have to call this function to discard. Oh, that's so fascinating. Yeah, so we need to call this function instead. So where I'm printing discard, we need to print... I keep going to the wrong computer. So where is discard? Where is that relative to everything else? It's like up towards the top. Okay. Oops. Come on. I'm working through a remote desktop software right now. Yeah, welcome by. Thanks for the subscription. Yeah, I'm working through a remote desktop right now so I can work on my Mac and my PC at the same time. So it's like I'm dealing with input latency. My key bindings don't work. This is a struggle. It's a genuine struggle. All right, but we're getting it done. So we need to generate this. Oh no, I didn't even copy the whole function. Of course I didn't. Didn't even copy the right thing. I needed the actual function. I need this. So instead of seeing discard, we discard fragment. Come on. We call this a metal provided function to discard the fragment. Okay. Clean and close this. Build and run. Okay, what happened? Oh, of course. Metal. What is going on? Copy. Metal. Failed to get fragment shader. Oh, I called it pixel shader. Let's change that to PS main. This will be FS main fragment shader. I think this will compile now. Hey! This is the first time seeing a seg fault is actually what I want. That's funny. All right. I guess I can actually show off the engine because I a lot of you guys jumped in just now. So this is like, what's going on? Yeah, so this is one of my. It's because I expect the seg fault in the normal control flow of the program in its current state. Because yeah. So for context of what I'm even working on is I'm working on the metal shader, like just the metal graphics backend. Because this is on a Mac, obviously. And up until now, I've just been using OpenGL on Mac. So this is like my demo project that I kind of just test around, like play around with. It's just a globe. Yeah, it's basically just like a Google Earth based, like, I don't know, simple. But it has like some complicated shaders and stuff, so it's a good test project to like actually, you know, use. But yeah, this is in OpenGL and on Mac. So the engine's cross-platform, so I can jump to Windows here and like run the same thing. I need to get the compile to work first though before I try doing that. Bear with me. Yeah, so here it is on Windows, of course. Same thing. Also OpenGL. You can like fly around. It's kind of fun. And then I can also switch to DirectX. So I have OpenGL and DirectX for rendering implemented. So here it is running DirectX on Windows. And I have like some other projects too. Like I have this little Terraria clone I was working on for a while. That has like some cool water physics. So like it is a capable engine at this point in that I can like actually make somewhat complicated things. Obviously it's just like a matter of how much time do I have to make games. But yeah, so the engine, and there's like the console, so it's, you know, it's a very feature complete engine at this point, I would say. But I'm working on getting Metal implemented as a render backend. So I can deprecate OpenGL, and basically it unlocks a lot of more modern graphics features that I'm kind of not able to support right now because of this bottleneck. And part of the complication of this is that in order to support all these graphics backends, I wrote my own shader language that I cross compile. And I was talking about this earlier. I cross compile from my custom shader language to like each target backend, depending which one is being compiled into the executable. So if I'm running OpenGL, it will generate GLSL, and then obviously DirectX would generate HLSL. And then Metal, which I'm working on today, will generate Metal code. So if I go back to this Metal project, you can see the generated Metal code from this. So it's kind of a complicated process to actually convert, because here's what the generated Metal code looks like. Here's like the fragment main function compared to the source, and this is the code you would actually write to like make shaders in the game engine. You write like this sort of common language. So you only have to write shaders once, which is really nice. So like the shaders just write it once and it will work in theory no matter what graphics is running under the hood. But yeah, getting the compiler to actually convert this into valid Metal shader code. It's kind of a process because there's just some quirks with how, you know, each of these languages expects things to be defined. But I just got it to the point within the last 10 minutes of actually getting through compiling successfully. And then I segfaulted, which is, believe it or not, a good sign. So, yeah. Let's go back to testing metal though. Okay, so segfault. The question is where? Shader init. Oh yeah, so I'm not even... Yeah, it certainly is intimidating. And yeah, that's not very helpful words, is it? It's actually they're hard in that they're hard. At least for me, it was hard to like visualize how they worked, just because of like how recursive compilers are by nature. Like, it's just not obvious how they work. But like once you kind of figure out like how they work recursively, there is a point where it clicks and it all makes sense. And I can say that from experience because it happened to me. It went from like this crazy thing I just didn't understand how they work to like actually I understand the flow of it now, which is cool. Because once you understand that, it's like you kind of open Pandora's box of what's possible. So like once I learned that, I was like, wait a minute, I could just write my own little shader translator. And the cool thing is with your, like when you do that, it's like there's a lot of information within the shader file itself that you can extract to help with like your render backend, because there's a lot of boilerplate that you need to do when you set up just like render stuff, you know, like if you're setting up DirectX in your project, you need to like, typically you need to like manually set the input bindings for like the vertex formats and all this other stuff. It's just a lot of boilerplate. But through the shader compiler, I can actually like automatically generate a lot of the shader like boilerplate stuff, which is really very convenient. Yeah, exactly. Yeah, Jonathan Blow, classic. I love John Blow. He's funny. Every so often I get recommended the Jonathan Blow clips YouTube channels. It's always funny. He's going on some rant about something. All right, let's see. So I need to actually figure out... Oh, I know what's happening here. So I had a segfault because I'm not initializing the system. See, the unfortunate part is my metal backend is literally nothing right now. So now that the shaders compile, it's still not actually gonna get me very far. But we need to call this resource init and free function. So we need to call this first off, and we need to free this. Yeah. And like the difficult part for me to figure out was the whole recursive descent thing. So you have operator precedence. That was really confusing until I like actually wrote it and sort of saw how it worked. Oh no, compared to failed to compile fragment shader. Reference type must have explicit address space specifier. Fascinating. Oh, my my screen just went black. 1 second. Every so often my little capture card thing just dies. Let me fix that. Yeah, you just joined. We were just talking about Tokyo. Yeah, I have seen him. He's a funny guy. I love the energy of his streams, you know? The crazy flashing like strobe lights in the background. Sorry, let me fix this capture card problem. Okay, I think it should be back. All right, it doesn't like this reference type must have explicit address space qualifier. I understand what it's saying, but I want to know if there's an easy fix for this. That involves not just removing it. Oh man. Yeah, and actually, I just recently fixed a bug with my compiler in that I was, I forget what's it called. There's an actual like term for this. But like the operator precedence goes either left or right. And I was going like right instead of left this whole time. And it, like, and that's determined by like how you construct your nodes or whatever when you're parsing the, like when you're recursively parsing, if you parse left or parse right. Yeah, right associate, left associate. I was doing it right associate this whole time, just as I messed up the logic. And somehow it didn't cause any problems until like one specific thing I was doing. So I must have just gotten lucky that I didn't even notice it was completely opposite. But then I fixed it and now we're good. But it's like little things like that. It's not, it gets tough. All right, what's going on? Click and drag. Metal. Okay, let's see. In metal indicates that a pointer or reference type in your metal string language is being used without specifying its memory address space. Metal requires explicit address space, qualifiers, device. So what do you say? I mean, I guess I could just pass this by value, I suppose. Doesn't really matter. Okay. I'll just pass it like this. Doesn't matter. Mm-hmm. Hey, here we go. We're back to the red screen. Believe it or not, this red screen is actually the expected result. This is the extent of my metal backend, but I now have shaders working. Or at least they're compiling. And that is good to see. So now it's just a matter of doing everything else. Okay, so I need to actually store these things. Well, I have a lot of to do here. I should compile these and then pass the bytecode. Wow. Yeah, you're up late. Yeah, thanks for stopping by. Appreciate it. Appreciate the chat. Fun times. Okay, so I need to leave it to do on this because we will do this up here. Allocate the resource, and then everywhere we do vertex program, we need to store this on the shader itself. Oh, that's actually crazy. You run like a whole C++ program while you're compiling. That's insane. Mm-hmm. Yeah, that's cool. Yeah, no, I haven't seen that. Okay, so let's see. Forgot one of these. I forgot to do this one. I don't know if I actually need this compiler thing. A metal library, a shader library. Because I'm passing it the source code, and I think I need one of these per compilation. Shader library. I'm going to call this vertex. I'm going to be moving all this stuff over anyway. Fragment. Yeah. Yeah, there's always people that are like way ahead of wherever you are. Okay, so bind shader. So what does this look like? So yeah, this is in my actual engine right now. Oh, I messed it up. What is going on? Duplicate member. Oh, did I duplicate that? Compute. And now what? Did I mean no template named? What? Can you not store these things on a class? Here, I need to look at my other project. Yeah, so I have this other project. So this is actually as far as I've gotten implementing metal at all. So this is my this is my metal test project that's not part of the engine. It's just like rendering a, I have a vertex buffer, I have a shader, I have some uniforms, and it resizes with the window. What else do you need? So I had the, I can't close this out. I had the bare bones in here, the proof of concept. So I create the program. I was gonna try and store this MTL function thing on a struct, but I guess it didn't like that for some reason. This is the weird Objective-C++ like hybrid, because you need to work with Objective-C in order to write metal natively. Yeah, metal is actually a surprisingly nice API. Like this actually isn't much code to get to this point. Like the renderer is 200 lines. The window is another like 200 lines. No, 300. And there's like some other stuff in here kind of related to rendering. But it's actually a lot less verbose than like DirectX, and certainly Vulkan. Okay, but how do I bind this thing to, how do you bind the shaders? So I create that, and then what? Okay, you bind it to the pipeline descriptor. So can I not store this thing on a class? What was it mad about? This error, it's telling me unknown type MTL function. Did you mean CG function? No, I did not mean CG function. I don't see what the problem is with that. Wait a minute. Yeah, that's interesting. I thought you could store these in classes, but I guess maybe not. That's kind of annoying because this is how I structure all of my backend code. This is where you go to ChatGPT and ask it why this isn't possible. And then it tells you some garbage, and then you see if it's even right or not. This is the classic AI, help me when I need it. Yes, absolutely. You can safely pass. So then how come that gave me an error? As long as I include metal.h. So what's the problem? What's the problem? Is this a fake error? Is it like actually mad about something else? This is the classic, look at this. Error, no template named ID. Where do I include metal.hpp? It's weird because it worked in the function. Yeah, I include this here. Is it because... And it works up here. I'm so confused. I don't think it would need a constructor or a destructor. I'm certainly compiling it as mm. Here, let's give it the error message and let's see what it says. Oh, I have seen that game. Yeah, the Kiora. I haven't seen that lately. I don't know. I haven't been following it, to be honest. I haven't thought too much about it. I mean, I feel like I'm tripping. This is clearly mad about this, right? This is like, it's explicitly saying this is not allowed. Did I include the H? Oh yeah, you might be right. Here, let me try the HPP. Maybe it needs the, you might be right. Oh, what's going on? Come on, compile. Metal.hpp is not found. All right, let me paste this first. It does say metal.h here. Okay, so make sure you've included you're using arc. So I don't know what that even means. What? Oh, whoa. Is this true? Is the compiler treating it like a metal shader code? That can't be true. I don't believe that. We can give it a shot though. No, I didn't remove that HPP. If this is actually the problem, that's hilarious. No, it's not the issue. I didn't think it was. That's crazy. I don't know what's going on. Let's try something else. Let's just put one of these. It's fine because it's okay with it in a static context. Let me just try putting some of these in the static and seeing what happens. Does it like this still? That should be fragments as well. What's going on? Vertex, vertex, fragment, fragment. Let's try this again. All right, so it's fine with it when it's not on a class. So this is certainly a problem. That's so weird, so bizarre. Here, let's go back to the AI, which is lying to me because it's certainly not true. Paste. Come on, think a little harder, AI. This is gonna be a problem if this isn't supported. I'll need to like store a static array of these things or something. Which isn't the end of the world, I guess, but not ideal. Oh, now it's expected. These are global file scope static variables, not part of my C++ class. Works perfectly. is in-class member initializers equal nil. C++ member initializers get tangled with C++ pointer semantics. Cannot parse. Oh, okay, so it doesn't like when it has an equal sign on it. If this is true. If this is true. I guess this is a C++ feature. This default initialization thing. No? Still not true? Yeah, right? Something went wrong. Yeah, of course, something did go wrong. Okay. Let me paste the code in. It's just gaslighting me. I mean, I could do it as a static array and just store an index to the array. Like, that's not the end of the world, I guess. I was just hoping I didn't have to do that. Because that's kind of disgusting. Wow, perfect. Not actually compiling Objective C++. It certainly is, because it works everywhere else. Yeah, I give up on ChatGPT. I will just do this for now. Well, actually, I need to make sure that this compiles. See, we'll have like a max GFX. Why am I not getting caps lock? So we have a total count of these things. I don't even know how big this is. How big is this? Can we have an array of these? Now I don't know. So rather than storing that directly, we'll just store an integer to it. And then we'll have to just index the array whenever we want to use it. All right, so I guess for now, what are we doing? Make new. Where's make new? Here it is. Make sure this is an integer. See if this works, because now I'm not sure. I guess it's redundant because all of these will be the same ID right now. Yeah, I should use Claude. I just don't trust AI at all on these questions. It's always worth looking though, because sometimes it does have the right answer and I save time. But a lot of times it does not have the right answer. All right, here we go. Does this compile? The big moment of truth. All right, there we go. We're in. I need to stop printing so much stuff. I'm curious what the size of this is. Let me print the sizes. I wonder how many bytes this is. API init, because I don't know like what these objects are. Stop. Oh, this is so fascinating. Oh, it should be vertex program. I thought it was erroring for a different reason. Okay. How big is this array? Oh no. I messed up. Wow, this is huge. This is huge. What? What is this? It's like half a megabyte. This is massive. Wait, no, that's like yeah, half a megabyte. 500 kilobytes. All right, I guess it's not that bad. Half a kilobyte, half a megabyte, just to store this static array. Can I default initialize these as well? Will it allow the syntax? It does. So bind shader is up here. So assert the resource is not null pointer. Yeah, Metal's complicated because more complicated than OpenGL and DirectX. Because everything, well, DirectX 11, everything is driven by this, where is it? This pipeline state. You have these these render pass descriptors that take in, or no, this is the render pass. We need the pipeline descriptor. Do I not have that in this project? You have this thing, this pipeline descriptor. And this thing is like, your pipeline state object for like the shader program, basically. So color attachments, these are like your textures you're reading from, I guess, or these are your outputs. These are what you're writing to. I think. So rendering pass. So it includes rasterization, multi-sampling, blending, tessellation, graphics, function state. It's kind of cool how you can control this. It's like the function called depth within the vertex shader. I assume that has to do with how much memory gets allocated to like the stack, I guess. Because the smaller, probably the better. It's cool that you have control over that though. Resets. Specifies the default rendering color attachment. Yeah, I'm just trying to work out the how I'm going to structure this, because I know you have to like cache these things, because you don't want to be making these every time the pipeline changes, like switches. I don't know if I can just use the main one though for the frame. I might be able to. Specifies the default rendering pipeline state, color attachments. So any array of attachments store color data, depth attachment, pixel format. Yeah. Is alpha to 1, whether force out channel values, color temperature to large represent value. Yeah, these are like your blend modes. Oh, but okay. So I have a render pass here, and what do I do with this? Vertex. Where do I use this? All right, we'll create a pipeline object. I don't know if all these functions actually take this. Well, I'll start with just the shader for now, I guess. basically pipeline.set. I don't have autocomplete, which is really annoying. So I need these two. We get this guy from our vertex program array. Okay, so that one's taken care of. And then at the end of this, we need to do this pipeline creation thing. So for now, I'm just doing it the basic way where I just create a new one every single time the state changes. But we should be caching these because you'll probably be reusing pipeline states a lot. So now what do I do with this pipeline state? We can print the error. Oh, I lost my error code. Let's do this for now. So we actually have to apply this thing. So what did I do here? Yeah, so we encode, we create an encoder, and then we have to end the encoder when we're done. So what is render encoder? Is that just a command encoder with description? Draw render descriptor. Oh, so a drawable render descriptor. Yeah, hey, thanks for stopping by. Yeah, it was a good time. I should eat too soon. It's getting towards dinner time. But yeah, I stream most Sundays, so probably this time next week. Maybe during the week too, I'm not sure. But yeah, see ya. Okay, so drawable descriptor. Job. What does job? What does that do? All right. Oh, I do have a drawable descriptor. So I make this at the beginning. Of the frame. Okay, I think I understand. I thought I had a bot. I don't have a bot. Should I have a bot? So I need to set up this encoder. Set vertex buffer, vertices, offset 0. At vertex. So that's for drawing. It's for uniforms. Okay. Oh, I didn't mean to paste. Okay, so we create the pipeline state and then we set the encoder. I spelled pipeline wrong. Pipeline. Call it pipeline descriptor. Okay. So what does my render encoder have to be? Render command buffer, what is this? So the end of the render pass, we end the encoding and we present the current drawable, which is what? Or we don't want to present here, we just want to end the encoding. So I think this is something I just set up every frame. Control render encoder. Yeah, I apologize if this is slow. I'm kind of like figuring this out. I'm trying to like map the concepts here to what I remember from when I was writing this for OpenGL and DirectX. So I have this like weird thing going on. So frame begins, we get the layer, the next drawable layer, and then we attach a render pass to it here, which is this drawable render descriptor, which comes from up here, where we create a renderer descriptor. Yeah, we need a render pass descriptor. Man, this gets complicated. Okay. I'm trying to work with what we already have. So let's see. We need the render encoder, that's next. So what is this? Do I have this? Let's just copy all of this. I don't have a render encoder. So render encoder, command buffer, render encoder with drawable render descriptor. Okay, so that's this. I'll make it with this Oh, I have that as a static. So I already do this. Okay. And we don't end decoding there. Okay. So we give the encoder the pipeline state. Then we need to begin the encoding. Let's see. So we where do we begin the encoding? What is happening? Okay, let's see here. Okay. Hey, how's it going? Welcome to the stream. Okay, so current drawable dot texture. So we need to do this. I'm not doing this currently. Right now I've just been creating a new swap chain, I guess, for every frame, which is pretty stupid. Yeah, I'm doing well. Making some slow but good progress on this thing I'm working on. Okay, so we need this render pass descriptor. Drawable.texture. Oh wait, I'm doing this. Okay, this is fine. The way I was doing this is fine. Create the encoder from the render pass, and then, yeah, okay, I understand. Canvas encoder. I'm working on getting Metal API integrated into my engine for a render backend. But I only like barely know the Metal API, so this is kind of a kind of a project. Okay, let's see if this compiles. Yeah, because this is called, what's happening? Why does copy and paste not work? Control C, Control V, just doesn't work. Through this remote desktop software. I can't spell pipeline with an E. Okay. It doesn't like this. Vertex program equals, what line was this? Oh yeah, I copy and pasted this, I forgot. So we delete that. Yeah, I've made games before in other engines. I kind of enjoy just programming generally though. So I have more fun making my own. Okay, so use of undeclared identifier pipeline. Yeah, of course. Because it is pipeline descriptor. Though this honestly isn't super fun. Doing metal. Okay, here we go. Error. What's it mad about? Failed to init pipeline state. Great. I guess I don't quite understand what the high level... What is like the corresponding structure for a render pass? Like the render pipeline is just the pipeline state object? Because it's interesting because this also has color attachments bound on it, which isn't, I guess, what I expect it to be. So like, what's the actual state? This is a good thing for GPT. I just need to understand like how these pieces come together. Because I know how it should fit into my renderer. Oh my god, that is not the line I copied. What is this? It's a configuration object that describes how to create a render pipeline state. How vertex fragments are connected, what render targets exist, binding, depth formats, etc. You don't use this descriptor directly for drawing. You create a compiled immutable render pipeline state, which you then bind at render time. So this is like your render pass, because it takes the shaders, takes the vertex. See, the vertex descriptor doesn't make sense to me because you can submit multiple draw calls typically within a single render pass. Oh, this is the pipeline state. Yeah, this isn't the render pass. The render pass has the attachment targets. But it also expects the format of render targets, which is weird. So I guess you just kind of have to like inherit these from the higher level state. The blend state. Sample count to label. So is an input roughly combines blend description raster, depth stencil. Okay, so like you just create one of these per pipeline state, and you kind of inherit the current render targets. All right, that makes sense. Yeah, so I make a new one. I attach, see, I needed to do this. Because this comes from and then label doesn't really have a label, I guess. So then what is the what is the difference between the render pass descriptor? Is that what this is? Am I just like losing my mind? Yeah, this is the render pipeline descriptor. Render pass. Blend modes, sample count. Any render pass with compatible formats. Yeah, so you create this on demand basically. And then these you create or draw a batch. Yeah, that's what I'm after. So yeah, this is fascinating. Yes, you have this render pass descriptor, which actually stores the textures. Then your pipeline descriptor needs to match for validation. So the shaders know how to actually sample the textures. And pipeline, how does it know? Hey, how's it going? Sorry, I'm kind of I'm in the depths here, in the trenches. Okay, so begin encoding. So it begins with this, and then it ends. Okay. Sweet. Yeah, I'm working on metal, and I don't know metal at all, so this is actually an interesting API. Made even more interesting because of this objective C++ intermixing going on here with the way you communicate with it. I think I understand this, though. So what is the permutation of this? Because it says store once, or created once at startup. But this isn't true, because this is like created based on, like, I wouldn't know this at startup, you know? This kind of like becomes known as I render stuff. It's just like when it sees a new permutation of this, it should make it and cache it. Yeah. That makes sense. It's like the classic pipeline state object, right? I understand that portion of it. Okay, I can actually start implementing this because this makes sense to me now at a high level. Store load action, store action, clear action. So this is like my render pass. So you have one of these for the swap chain, obviously. Wrong code. Wrong program. I'll just stick with what I have. So you have vertex, fragment, and then the color attachments need to match. So this is just the pipeline. Where do I use this? So you create the encoder based on the render pass, or the yeah, the render pass. Which I am not changing right now. So I just need these. So I encode and then I draw my encode in the encoding. Okay. So I do want to present the encoder is just this. All right. Does that make sense? So pipeline state, pipeline. Where's pipeline? Here. Yeah, let's put this up here. So this is the render pass, this guy, and then you set the render pipeline state with this guy. Okay. So we create our pipeline descriptor. And we device. Failed to init pipeline state. Why? I need my little error thing. As a static. What now? Okay, so what's the problem? Vertex function has input attributes, but no vertex descriptor was set. Okay, that makes perfect sense. That's like a valid error with my current setup. Oh man, this is a project. Yeah, vertex has input attributes, but no vertex descriptor. 'Cause obviously, I don't have a vertex descriptor. So what does that look like? A metal vertex descriptor. I have one in this other project. So I will need to generate this as well. Let's see. A metal vertex descriptor. So we have vertices. Okay, I don't have a vertex descriptor. Okay, what is this? Descriptor. So I need an MTL vertex descriptor. Layouts. An array of state that describes how data are fetched by a vertex shader function when rendering primitives. I wish there's just like an example on here. Like, just give me an example of what this looks like. You know, this doesn't tell me anything. Obviously, I know what a vertex descriptor is. How do you use it, you know? How am I supposed to interact with this object? So, attributes, here we go. An array of state data that describes how vertex attribute data is stored in memory and is mapped to arguments for vertex shader function. Okay. So this is what AI is good for. I'm going to ask the overlord. Because I already have the shaders being generated, but I need to generate their input bindings. Let's see, output, generated, shaders. Because I know in DirectX you fill out this struct, you have an array of these structs. I assume it's exactly or very similar here. Where did my... Oh my god, things just do not copy when you ask them to. Copy. Paste. So you have yeah, this is neat. Yeah, because the way I do it with DirectX and OpenGL is I generate these. Like for example, if I go into the globe project, projects, globe, output, generated. See, like I do this input generation for DirectX from the shader code, right? So it like maps the semantic to, you know, the format. Then you know like the byte offsets of these things. So I basically just have to do this exact same thing, but for metal. All right, but I'll be back in a second. I need to take a short break. All right, I'm back. Okay, let's see. Let's speed run this. So essentially I just need to generate these things. And this will need to be an Objective C++ file as well, which is unfortunate because that complicates things a little bit. So when I generate metal code, what is happening currently? Oops, I lost my chat. So step rate is what? Okay, I'm going to save this as a reference because I will need this. So and what's the list of these? I need like a list of all of these. Okay, I'm going to do this on my main computer for a little bit because this is a pain. Okay, so we sync this. This is an Objective C++ file. So we need to change the extension to be .mm. We need to import, what did it say? Import metal.h. So basically need all of these. And the header file needs to be this. Let's see. Metal input layout description. This needs to be deleted. So this thing is actually corresponds to this metal vertex descriptor. Which I'll actually leave as a void, because that's easier to reason about. Because then I don't need to care about Objective-C++ in the header file. Okay. So that's a void. I can delete that. So that gets that. And then I'll input layout descriptor. Let's commit this in a second. Is this real? I don't know if this is true or not. Yeah, I didn't think so. So, what are the enums? Ouch, my eyes. So it's just dot float 3. Doesn't seem right to me. Let me just start generating this thing. So let's see. In the back end, in the shader generator, we have a function that does this already, that I'm already calling, I believe. So this function. So it basically needs to be like this. So okay. Let's delete that, and we can delete delete that. So this needs to be where to go. Here. So we basically need to generate this. So we have the offset. And hey, how's it going? welcome back. All right. Offset.buffer index equals 0. I believe that's what that wants. Because that's the vertex buffer. All right. So this is this index. What do I do for OpenGL here? Actually, I think that's fine. So the format is this format. I will tab those. Working on getting metal up and running, which is quite the project actually. So let's see, format size. I calculate the offset in here somewhere, don't I? Offset, byte offset, yeah, here we go. And then that on there. Then the index, so format, index, per instance. I don't need any of this. Step rate is not important, I don't think. Okay. So now it's a matter of getting these, oh, I didn't do this, byte offset plus equals format size. Ear itches, okay. Attributes, attribute, offset, index, okay. So now we just need to fill this table. All right, I'm gonna cheat. I hate to say it, but I'm gonna have AI do this for me. Here we go. Come on. Yeah, but I want these as a string. All right, whatever. This is the kind of stuff AI is good for, is like doing all this boilerplate. Because this is an annoying mapping to have to maintain. What is it saying? Okay. Okay, I'm gonna shamelessly steal this. I'll have to it didn't even work correctly, actually. I'll just reference this. So unorm is a uchar2 normalized. Is that true? I guess this would be 2. Oh, I started at the wrong one. Oh yeah, this is fine. I was like, what is happening? I guess this really could just be a table, but oh well. Rather than this huge cascading switch statement. Your whiplash over here. Hey, how's it going? Welcome to the stream. Crazy how many different formats there are for vertex, like layouts. It's like this huge permutation table of just different formats. This is why I want to do the shader compiler. So like, I do this one time and hopefully I just never have to think about this again. Because this is not too fun. Okay, so we get that. Wow, what a project. All right. So that should generate the index buffer or the vertex buffer description. What is this? Semantic name. What does that generate? I don't even know if I need this. Yeah, I don't think I need this. Yep, it is. Yeah, pretty much. Yeah, I can demo it actually. I know it's more interesting than watching me just like do nothing too interesting. Let me see if this compiles still. Yeah, here we go. Yeah, so the engine has a, I'm running my own like renderer basically, render abstraction. Because I'm working on metal at the moment. Nice. Yeah. So yeah, obviously I have a DirectX renderer and then like the OpenGL renderer if I switch to OpenGL. Now what I'm working on right now is I also have my own shader language that I cross compile into the render backend. And from the shader language, I compile some of the I generate some of the boilerplate C++ code that the, I guess the render backend like actually uses to sort of bootstrap itself. And one of the big ones that I generate is the input binding descriptions for the vertex and instance formats. So I extract it straight from the shader code. And then that's what I'm working on right now is like generating the C++ code that Metal will now use to like set up its input layouts. And yeah, I'm just doing that. So what is this? Semantic index. This is unnecessary, so I can delete that. Might offset, we need this. Yeah, it's quite the project, but it's cool when it actually works. Like for instance, I can show that. So like I just rendered the little globe project. So this is my custom shader language, which is kind of like a universal language. This is like what I write the actual shaders in. Like here's the atmosphere shader for that globe. So when I actually build, I'm running OpenGL, so obviously it needs to be converted to an or a GLSL shader, because that's what OpenGL uses. So as part of my build stage, when I'm like processing the assets and everything else into the binary file for the game to load up, I compile the shader and I cross compile it into here's GLSL code, equivalent from that shader file. And then like if I switch to DirectX and I just rebuild, and I write these to a file just to like debug. Here's the same shader in HLSL, and I just wrote the same the backend for the compiler for Metal earlier this afternoon. I'm on Windows right now, so I can't actually. I guess I can demonstrate that. I can demonstrate that here. Like here would be like the generated Metal code. So like obviously your code needs to be compliant with the whatever API you're using. But yeah, beyond the shader code, I also generate the input bindings, like I said. So like for DirectX, for all of the different vertex formats that my shaders specify, I extract that information and I basically generate these tables. So then when I go to bind the shader, at runtime, I can just load up this, like the input description from this table I've generated. What's cool is that means I can rapidly make shaders like with unique vertex formats, and I never have to actually think about it when I'm like making my game, because the engine just does it all automatically. So yeah, it's like what it looks like for DirectX. If I switch back to OpenGL, it's like the same sort of concept. So like this is what, OpenGL requires you to do when you have your own custom vertex format. You have to specify like the attribute pointers and stuff. And then here's like the table for each shader file has its own vertex format associated with it. I don't know. I don't even think I'm that good, to be honest. I've been programming for a while though. like I think it's about 15 years I've been programming. I've been doing C++ for about 5 to 6 years, I guess. Depending on how you define the start date of that, it's kind of not an on or off. It just happened. But yeah, so metal, the metal equivalent of this whole thing looks like, I have it just at the top of this file for reference. This is like what the metal expects you to have. So you need to create this MTL vertex descriptor object, and then you set the attributes like the format for each field, and then like the offset. So yeah, it's just a lot of it gets complicated because like there's like a million of these MTL vertex format things, because like there's so many different vertex formats you might want. This is kind of interesting actually, because so like if you have a vertex format in your shader that you read as like a float, a 4-byte float, you can pack it as, say, like an integer, like an unsigned int. Like say you're doing like a voxel game that has chunks, then you know your vertex positions are always going to be like integer values between 0 and 255 or something. Your shader code would still read it as a float, like interpret it as a float, but the way that the GPU knows how to interpret a uint 8 to a float is determined by this input layout format thing. So you can imagine like this would be like a uint 8, right? But your shader would have a float. That's how it knows how to map. So that's like why this is important. And that's why this offset is important as well, because like a uint 8 is only 1 byte, but a float is 4, so it needs to know like how to actually read the memory when your shader's like executing. So it's interesting. It's just a lot of work. It's a lot of work to get this set up. And for some reason I'm duplicating this twice, so I should really not be doing this twice for some reason. Why am I doing this? Okay. So I think this works for the GFX vertex. I need to come down here and actually do this final piece here. This layout for buffer 0. Yeah, because buffer 0 is your vertex buffer, your vertex format. And buffer 1 is your index buffer. So if you have an index buffer, you would specify that. Or maybe that's not true. I need to think. Well, I'm just gonna keep writing this for now. GFX instance. So this goes down here. What happened to my... Uh-oh. Oh, vertex. What am I doing? I'm starting to lose my brain here. I've been going at this for a while. I want to get this piece done, and then I'm probably going to end the stream for the day, because I need to go eat. But I'm almost done with this. So at the end of this loop, we need to write this. So you always have a step rate of 1. That would be weird if you didn't. And then this needs to be the formats, the byte offset, I guess. New line. Is that true? I don't know. I'm just streaming. It's kind of fun. I haven't really kept up with what other people are doing. I'm like a recluse. I need a semicolon. That's kind of surprising because most game engines are in C++. I guess that's not true. There's a lot of non-C++ ones these days. Maybe I should redact what I'm saying. Okay, so this should be static. What is this? Yeah, that's true, actually. Yeah, you bring up a good point. Yeah, eventually I want to get scripting in my language, or my engine too. I'm going to do what I did earlier. I kind of like this. It separates my tabs. Otherwise you overwrite those on accident all the time. And that's a long line. Let's see. So you have the format, offset, buffer index. We can increment size here. And then, let's see. I'm like changing existing code. I'm like refactoring code I already wrote for the DirectX stuff. That's why there's like an intermixing of things going on here. Okay, so CP or MM. So metal input layout description vertex is a metal input layout description vertex description. Yeah. I like compiled stuff too, personally. Okay, so how do I test this now? Generate structure. I guess I have to commit this. And go back to my Mac. GFX. I have this annoying setup where I have I'm working on my Mac right now through a remote desktop. So I have like input latency and my key bindings don't work. And the resolution is bad, but it works for now. Okay, so source, backend, build, GFX. Here, I know this won't compile, but let me see what happens. Oh, it actually does compile. Wow, fascinating. All right, here's the, so this is the stuff we just generated from this. So does this look correct? Yeah, it does. I don't know if this actually compiled though. I need to make sure I'm compiling the source files from the backend with metal. Yeah. Yeah, I do have my Mac hooked up, but then you wouldn't be able to see it on the stream. Plus, it's nice to be able to jump between them fairly rapidly. Okay, let's see. Need to make sure I am output that generated. Yeah, so we need to do this as well. Dot mm. Yeah. Yeah, it's like actually one of the main reasons I got a Mac is because I wanted to support. Well, I don't know. I don't even know. No member named attributes in. Wait, what is this mad about? But yeah, that's one of the main reasons I got a Mac is because I wanted to be able to like develop for the Mac ecosystem or the Apple ecosystem. Yeah. Well, the problem is that if you want to target iOS as like a target, which I don't even know if I want to be honest. Like I'm not too interested in mobile games, but the challenge seems interesting. Yeah, if I want to target iOS, I would need to also support Metal with the rest of the engine. So, okay, so what is this mad about? Let me think. I'm trying to think what my like API for this should be. So what am I doing with this thing? So we branch on this based on let's see. Yeah. Yeah, that's a good point too. And a lot of people say like there's no game, like nobody games on a Mac, which is like objectively true if you look at the stats. Like it's like less than 1% of Steam users like game on a Mac. But there is a bit of a chicken and egg problem. It's like, well, if no one games on a Mac, then no one makes games for Mac. And if no one makes games for Mac, then no one will game on a Mac. So I just figure it's like, I don't know. Practically speaking, I'm probably wasting my time right now. But I think it's a worthy exercise to like at least, I don't know. Maybe as a purely academic endeavor, it's worth my time to at least learn how Metal works as a graphics API. That's the cope that pushes me forward. That helps me sleep at night. Okay, what's going on here? Desktop count. I'm like losing my brain. I need to eat. That's what I'm working on right now. Yes. Is Metal. It doesn't work yet. I'm working on it. The idea is that the renderer is swappable with different APIs. Okay. Okay, what's the problem? What am I doing? I have to think for a second. So this obviously doesn't exist because I need to cast this back. So let me update this code. Where's my Metal generation? Shaders. So rather than using desk, I should be using MTL. I'll name it like MTL or something. So this should be MTL, 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 MTL. And I need to write the count as well from this, I think. Where's it getting this input description from? This is yeah, you might have just joined. I explained this a second ago. This is, I'm in a remote desktop right now into my MacBook from my Windows computer. I also have Linux running. So if I switch to Linux real quick. Here's Linux. So this is demonstration that it can also run on Linux. So here I'm on Linux. So I've got a lot happening at the moment. I have 3 computers. And the switch that lets me jump between Mac, Windows, and Linux. But I can't stream through my Mac because I don't, well, I could, but I just don't want to. So I'm using this remote desktop to access my Mac, even though it's literally sitting like 6 inches from me. Oh, those hashes. Wait, what are you looking at? What are hashes? They might be. I don't know what I had on screen, to be honest. Okay, so what is the problem? No member name attributes. Okay, so MTL. Let's work at this one step at a time. Oh, these? Yeah, this is disgusting. This switch is disgusting. This is mapping. I'm basically writing a converter for vertex input layout types so that you can like, I don't know, it's just easier to see the example. I just showed this a little bit ago. I feel like I'm on Groundhog's Day a little bit. That's fine. Output generated shaders API. Okay, so like in OpenGL, when you set a shader that has a custom vertex format and you bind the vertex format, you need to specify like how the data is laid out in your buffer so that the vertex shader actually knows like, you know, what the layout is when you actually use it as variables in your like shader code. So in like OpenGL, you specify all this stuff. And like DirectX has the equivalent, and Metal also has an equivalent of this. And I have a shader compiler that cross-compiles to HLSL, GLSL, and Metal. So I generate these from the shader code, basically. This C++ boilerplate. And this giant switch statement is just mapping my shaders types in my language to the types that like Metal expects, I guess. And there are a surprising number of these. And I should just use like a table rather than a giant switch statement. But that's a problem for another time. Okay, so first I need to go up to the top of this. I need to do some crazy reinterpret cast. So what is this thing? This is I'm generating this right now, basically. I'm using, I actually load them directly, so that's why I use that. Yeah, it's kind of weird. I should fix this eventually. Where is my backend for? Yeah, I know what you're talking about. You're talking about like the like, yeah, it's like the NGL stuff. Oh, of course I won't actually find any when I need it. It's like this NGL delete stuff. Yeah, It's because I'm using I'm linking to OpenGL like directly. And it was this weird problem where if I used the names themselves, anything that wasn't in like the OpenGL core like 1.0 profile, you would get like a name conflict, a namespace conflict with the original names, like by doing this. And I forget exactly what this was. It's been like a long time since I actually tinkered with this. It's because on on Mac, Windows, and Linux, they actually use like slightly different OpenGL like implementations because they have like their own interface with it. So yeah, it's just like, yeah, it's a pain. Thankfully, I don't have to deal with that with the other APIs. Yeah, so the N in front of the GL is just like me redefining the name so I don't have like a conflict. All right, where was I? Build shaders. So keep jumping around. I have this crazy latency, so I need to get this pointer. What do I call this? A desk.desk. What is going on? No, I don't want dictation. Stop. Yeah, so my strategy has been, I first get it working. So like with the metal stuff right now, I'm just getting this working. And then I go back after that and I clean it up. It's very iterative because like part of this is I don't know the metal API very well. So like I know I'm going to mess this up. In my first go at it. But yeah, like a lot of this I will clean up. It's just like, I don't want to waste time trying to make the perfect, like writing the perfect code before I even know what it should look like. All right, so let's see. Like, why does this not give me a result? Here we go. Let's do double new line. So this should solve one of my compiler errors. I need a more efficient way of doing this. I just get lost in the file system. Okay, so this should now use this. I mean, for the graphics stuff, I already have OpenGL and DirectX 11 working in a pretty good state. And it's now just a matter for like metal. Like I can show you this really briefly to kind of show what I'm doing for greater context. So like I have my graphics module, I guess. So like this is my API at the engine level, like Manta /graphics. And this has a bunch of functions on it, right? Obviously. And there's like the ones that are supposed to be exposed publicly that the games actually use. So that's like these like GFX : namespace functions like bind texture, you know, like initializing texture resources, all the stuff, binding shaders, setting like just all the graphics state. And then each backend, so like the DirectX backend is this one, is like the actual implementation of these concepts. So I kind of have it organized where like every backend implements the same functions. So like I have like setting the swap chain size if like the window resizes. So like I have this core graphics API underscore sort of thing. And then OpenGL has like the exact same thing, like API set swap chain or swap chain set size. So this is like what OpenGL does when the swap chain has to resize. And OpenGL actually like gets the swap chain from the window, so it kind of manages it for you. So you don't actually do anything here. But like now that I'm working on Metal, it's like my API swap chain. I just have nothing stubbed in here yet because I haven't implemented it. So like when I'm working on Metal now, it's just a matter of filling these functions in pretty much. And I'm working specifically right now on like the pipeline state object for the render commands. So like basically this function down here. And I'm at the very top, so I like just started. But like part of the pipeline object is the shader that's bound. So like when I bind a shader, what has to happen? It sets like the pipeline descriptors, vertex and fragment function. And then the next step of this, which is what I'm working on now, is like the vertex and input buffer layouts. So we need to set those as well because the pipeline descriptor expects to receive those. Whereas if I go to like this function in DirectX, let's see, wherever it is. See, like you bind these shaders and then you set the input layouts. And then I have these generated function calls from my like backend here that I'm generating boilerplate. So then depending on which shader is bound, it will, you know, bind the correct layout state, I suppose you could call it. So yeah, it's just like a matter of, because at like a high level, all the graphics APIs do the same thing, right? Because you ultimately have, you know, a graphics card. It's not going to be, it's not going to be that ambitious. Yeah, because those engines have like editors and stuff in like a UI. So mine's like purely code driven, like it's kind of traditional in that sense. And I'm just developing it for like myself right now. It's not a product. Am I copying Tokyo Spliff? No, I don't think so. I hope not. Maybe he's copying me? Question mark. Nah, Tokyo's great. He's got some funny content. All right, so what's this mad about? So it doesn't know what the dot is, obviously. That guy is wild. He's so funny though, because it's like, you know, programmers kind of have a bit of a stereotype, right? And he does not fit the stereotype for a programmer. It's just funny. It's so entertaining. All right, so I messed this up. Man, my copy and paste doesn't work either. It's so frustrating. This should not have a dot. All right, here we go. Here we go. Making progress. Use of undeclared identifier input description. So where is this? Yeah, I mean, it's probably would be faster if I just wrote the code from scratch instead of trying to like shoehorn the DirectX code that I had into this. So what is this? I'm setting this directly, so I guess I don't need that. This is how many there are. Okay, so I don't need this in here. I actually need to look at the OpenGL stuff for a second. Yeah, this passes in the location. I need this, I think. Yeah, I mean, I do this mostly for fun, so it's all right. I'm not too stressed out about it. I enjoy the process of like making the engine more, honestly, more than the games sometimes. So it's just, I don't know. I like it's just like the problem solving, you know? It's kind of like a mental activity. As for context, I have a full-time job, so I just do this for fun. I'm not like in this for, I'm not in this for like making some next big product. At least right now, you know? You never know. Okay, so I need to pass this location thing. So this should be... it's just fun. It's like addictive. It's very addictive. All right. I'm getting closer. I'm almost here. This is a big project. This code generation. This is the ugly stuff, to be honest. This can be index. And then this needs to also be index. So I'll pass that in when I call this function. So that's how it knows where it is. What buffer is the... Yeah, and that's true as well. Okay, so let's see, what's next? So where do I generate this thing? Everywhere where I call this, I need to also pass index. If my copy and paste would work, that would be nice. I don't call that anywhere. What? I'm confused. I mean, I don't think that's true, actually. I think you should target multiple platforms. Because if you're writing an engine yourself, like, there are a lot of assumptions that you could make if you're doing it for just one platform that would severely bite you in the ass if you ever want to do multiple platforms down the road. I think you should do at least 2. It's probably more realistic to do Mac or Linux and Windows. But there are a lot of non-trivial differences between the operating systems. And if you don't write at least your engine high-level code to like be able to bridge those gaps, then you're going to be doing a lot of work if you ever want to support multiple like different backends in the future. It's not easy to like backport that. It doesn't even take that much more time, to be honest. I don't agree that it takes that much more time. Like I'm writing this metal code in like a couple days. It's not like that significant of a time investment in the grand scheme of things. I don't know. I just don't think it's as dramatic as some people make it out to be. I mean, I guess you could make the counter argument that like I put a lot of time into like yeah, it does take more time. I would be stupid if I said it didn't take more time. I don't disagree with you. I just don't think it's like as negative as a thing as it can be made out to be. I think it's fun. You have to ultimately get to the question of why make your own engine at all. And if you're in it just to make games, then yeah, I fully agree that it's not a good use of your time. Like, I agree with that. Like, this is certainly, if my goal was purely game development, this is a complete waste of time. Especially because there's so many great engines out there already. And that's why I emphasize that I'm not making a product right now. I'm doing it for fun, and I'm streaming it because it's interesting. Or at least I hope people find it interesting. I don't know. I have some good conversations with people in here. It's pretty fun. Yeah, true. You could write like a web wrapper. Do like a web GPU and then just start a web context or something when your app starts. Okay, so this is mad about this. I think the slowest thing is working through this remote desktop tool. So where do I generate this? Here we go. I found it. We need to do the same for the instance. Yeah, I don't disagree with you. I guess from my perspective is that I program as a hobby. Right, so I'm not in this for the money. I have a full-time software job that I make a fairly good amount of money from. And it's like, if I were doing game dev as a income stream, I think it would be a waste of my time because I make more money in my job than I do, reliably through my job than I do through game development. But I still love game development because that's how I got into programming. So it's fun for me as a hobby activity to do it, right? And I think it's just an intellectually stimulating thing to do, to like write code that's low level. So that's personally why I find it like justifiable in my life to spend time doing this. Yeah. Like, I don't know. It's just the truth. And like, I like working too, actually. Like, some people hate their jobs, but I like my job. Like, I solve interesting problems, and it's like, it's not very stressful. I'm in a good position where it's not too stressful, the work I do, like, professionally. And I think a lot of the skills I learned just doing projects on the side do translate to like stuff I do like as a job. So it's not like I'm wasting my time like refining my skill set in, you know, engineering. Okay, so what is it mad about? Redefinition. Void pointer array. What is this mad about? I should just switch back to my main computer. I guess I just disagree from experience, because I did do that route with an engine I was doing prior to this one, and I ran into problems with things I didn't like consider by doing. It's like the same reason I support all the C++ compilers. Like, I don't just compile with MSVC, I compile with MSVC, LLVM, and GCC. Yeah. It's like there's just like, I don't know. I think if you just want a robust code base, you should, I don't know, support multiple things, but it's just an opinion, I guess. I'm not forcing you to do it. All right, I am certainly not making good progress on this. Okay, I need to switch back to my main computer. This is, the fact that I can't reliably copy and paste is killing me a little bit. Like, I press paste and nothing happens. All right, where are we? So where do I generate this? Because this is what I need to change. Yeah, here we go. All right, we are back. We are back to an error state, which is great. An error is a good error. Like, we've made it past compilation, and now we're actually at a runtime error. Taking the scenic route to get here. I mean, if you want to look at the code base too, I have the link up there somewhere on the Twitch, I think. I've made a lot of decisions which are not conductive of efficient use of time as part of this engine. So, yeah. You could argue that it's almost purely academic, right? All right, so let's put a new line there, and we can move on to the vertex format, or the instance formats. Well, I used to work at a AAA game studio. I used to work for Activision, and yeah, they don't support Mac, and I know the reasons why. And it's basically exactly what you expect. It's that there's no money in it, right? So why would you dedicate engineering resources to support Mac when there's nobody playing games on Mac? And maybe that will change. You know, they do have mobile games, so they did put some resources in that direction, but yeah. Okay, so let's see. I think I should be able to just bind these vertex formats, actually. Let me just see if this works. So how do I bind this? I don't even know. Is it just when I come to bind the shader, I need to call these functions? So bind shader. I need the OpenGL version. This isn't even the right thing. What do I call this function? Come on. No, that's not what I was looking for. I mean, I don't think they'd waste time writing a Windows emulator. I mean, I don't know. I don't know if I have any final thoughts on the argument, on the issue at hand. I guess I have, through this project, I have quite a bit of experience now working like natively with Mac, Linux, and Windows. And I don't think it's like that insane to just write stuff natively for it. Especially if you use the standard library, which does a lot of, the hard stuff for you. Like the file systems and all of that stuff. You're pretty much just using, maybe creating a window. And the amount of code to create a window is surprisingly small. It's like 100 lines. At most 100 lines of code on each operating system to natively create a window using their API. It's just it's not that much code to maintain, I don't feel like. If I can get this far as just one guy working on his free time, it's like it should be nothing for a big organization to do this. And maybe there's people like me that work at the big organizations that find this sort of thing fun, and it's fine. Is hire people like me, I guess. And that's kind of what I was doing at my other job. So, what am I doing? I'm just twirling around, scrolling around, not doing anything. Okay, so when I go to bind this, we need to go to this function. I'm gonna call metal input layout description vertex. We'll assert that that's true. Vertex format comes from what? The shader, I guess. I guess it needs to know the vertex format. Yeah, resource vertex format. And then we need to initialize a metal object like this. Create one of these. And then from that, we need to also create a metal input layout description. We'll pass this guy. And we pass 0. I mean, I guess we'll see if we ever get to that point. It might be fine. Or it might not, you know. Maybe the ship will sink. Who knows? I guess we'll see what happens when we get there. Did he make his own engine for that? I actually don't know the story of Stardew Valley. It was written with Microsoft's XNA. Well, that's your first mistake, was using XNA, to be honest. Didn't Terraria use XNA as well? I mean, that's not even like an equal argument. That's like you're using Microsoft's framework and then having problems when you're trying to cross-platform a framework made for Microsoft's like C# ecosystem. I mean, to be fair, you've kind of walked into a minefield before you even, you know, started moving when you make a decision like that. It's like Minecraft like did Java, you know, from the beginning, and then Microsoft came in and had to like rewrite Minecraft in C++ because they realized making Minecraft cross-platform with Java was an impossible task. All right, so we have this description. I need to clean up this API because this is disgusting, what I'm doing right here. I should just pass this thing directly. Maybe I will. I'll do that directly. Or at least pass it as a void pointer. Yeah, let's do that. Well, I'll do that later. Bear with me. Bear with me while I don't know what's happening in my life anymore. Okay, does it still compile? No, it does not. So, did you mean... Yes, I did mean that. Wow. I gotta say, working in this remote desktop tool is not enjoyable. Why am I doing this as a reference? Yeah, I don't have a vertex format stored, so let's store that. Okay, let's see. Did I mean... No, I did not mean vertex format lowercase. Did I typo? Of course I did. It's funny how this thing has like feathering. You can kind of figure out what you meant to say. No, you... Location, yeah, location plus plus. I guess I'm not using this, so we can move that for now. I need to start proofreading the code I write. This is the brute force it and clear every error until it compiles method. Did you mean abort? What? Did you mean vertex format? No, I did not mean vertex format this time. What? Did I mean vertex format? Oh no, I didn't mean vertex format. Maybe I did. I have an inconsistent use of variable names here, I guess. That's another to do to clean that up. Because that's confusing. I have vertex format and then vertex format ID, which mean the same thing. Okay, cool. So we got to the runtime and we errored. So now in theory, I should just be able to bind this thing to the, when I click bind shader, I should just be able to, so what is this? Pipeline descriptor dot vertex. What is it? Vertex layout? I don't even know what this should be. Because I don't have... Oh yeah, I tried C-line once, a while ago actually. It was alright. I don't have too strong of opinions either way. Okay, so... This is where I asked ChatGPT how to syntax this, because I don't have autocomplete because I'm not using Xcode for this. What is going on? Maybe I should just boot up Xcode. Yeah, okay. Yada. Pipeline. Vertex desk. So what do you do with this? Vertex descriptor. Here we go. Vertex descriptor. How does that not... Look, you highlight the whole thing and it doesn't replace it. Yeah, I haven't done Vulkan yet, so I guess we'll see. We'll see how that goes. All right, now we watch this fail catastrophically. Failed to bind pipeline state. What? Depth attachment pixel format is not valid and shader writes to depth. Does it really? I guess it does. Yeah, I do write to depth. Wow. I forgot I had that in there. Yeah, we can remove this and we can remove this. It's almost as if, oh, here we go. Here we go. We committed command buffer with uncommitted encoder. What does that even mean? Commit command buffer with uncommitted encoder. I thought we did commit the encoder. I guess not. I must have not done that. What am I doing? Graphics, metal. Do I need to commit this thing? Do you need to commit your encoder when you're done with it? Let's see. No. Where am I committing my buffer with uncommitted encoder? What does that even mean? Commit. Where do I commit? At the end of the frame, and then what? What does that even mean? It's so true. I only commit in one spot and it's here. So maybe I should be committing elsewhere. All right, here we go. Here's what you do. You copy this and then you have AI hallucinate at you again. Make sense of this, please. I guess I did start an encoder here, didn't I? Maybe I shouldn't have one here. Oh, there we go. There we go. Vertex function must not be nil. Wow. We saw at least like a half a second of window there. Check this out. It's my metal renderer. Half a second. Okay. So, render pipeline descriptor validation. Vertex function must not be nil. How could it be nil? I thought I checked that it's not nil. Copy. Okay, so, I mean this, I will error if this is nil. Paste. Let's get the program ID as part of this output. This is so annoying. Yeah, I definitely do. I'll do not equals nil. Not equals nil. Be explicit about what we're testing. All right, it is nil. Fascinating. I guess not. No, it's. I don't know what's happening with my little remote tool here, but my keyboard bindings don't work, and I'm like, I feel like a caveman right now. I'm really click and point. I can't multi-line edit either because that's not working. Half the time my shift key doesn't work and things are just lowercased. Really is a struggle. Okay, this was nil for some reason. That's fascinating. The only time that should be nil is if it failed to compile. Or this is nil. What am I doing? It errors if it is nil. Yeah, it is. I can multi-line edit when I'm actually using the Mac. But for the sake of the stream, I'm powering through with this, what is happening? With this remote editing here. Oh no, now we have like 50 of these rendering. Render pipeline descriptor validation. Vertex function must not be nil. It isn't nil. Do I need to pass this thing by a reference? A pointer reference? Is it not like mutating the actual thing? The infamous pointer reference? No, certainly not. Well, now I'm confused. I'm thoroughly confused. Whoa, what just happened? It's so true. What was it mad about? Here. We know that this is gonna be true. I don't need to print that. Oh. Whoa. Oh, no, that was just a lie. All right, so this state isn't, Here, let me pass. I'll pass the pointer to it so that we actually mutate the right object. I don't trust the objective C++ compiler to actually understand what the pointer reference means. The infamous pointer reference. So we have a pointer and we just have to dereference this thing. So yeah, sure. Oops, it should be this. It really is. Oh man, it doesn't like that. Uh-oh. What? What is happening? Here. Is it not like this? Is it not dereferencing my pointer? Here, let's be fully explicit about what's happening here. Here we go. Fully wrap this guy. Who has any clue what you're looking at, to be honest? Oh, it's because I wasn't checking in my error, so this was actually fine. Ah. But just for verbosity's sake, we'll do it. All right, I think we errored again. How is that nil? It's pretty normal. I don't even know what's going on half the time either, to be honest. Yeah. I don't understand why this thing is a pointer, actually. Should this even be a pointer? It's annoying because this is like Objective-C++. So it's like this weird mix of Objective-C. So you get like this crazy stuff going on. But then you also have C++ like everywhere else. And you know what? I don't even feel confident that this is the correct way of initializing this thing. It's not behaving like a typical C++ thing to me. But I do it up here. No, that's actually not fine. Yeah, it's something. I think it's just newing an object. It's like calling malloc. And it's a pointer to it, right? But then for some reason it uses the dot. Let me look at the other project. I have to look at my other metal project here because I do it here somewhere. Okay, so this is the render pass descriptor. Where's the render pipeline descriptor? See, in the render pipeline descriptor, I'm doing it with a pointer. Is this even valid? Render pass, render pipeline. Let's just see if this compiles if I remove the pointer, because I don't know what's happening. This just feels off to me. I mean, it makes sense. It's like a pointer to this thing. But then why are these dots? Should these be arrows? My brain hurts. Yeah, look. Interface type cannot be statically allocated. So it needs to be a pointer. Here, let me ask ChatGPT. How do I pass this thing to a function? Because that's ultimately what I'm trying to do. The mechanism I'm trying to achieve is like a pass by reference on this object that I've initialized. All object types, ID, arc, or concrete are already reference types. You don't need at or pointers like in C++ passing objects. So you just pass it directly. So this was what I was doing, pretty much. So what was wrong? Let's put this back. No Minecraft. No, I'm not playing Minecraft. They are reference counted, I think. Yeah. Okay, so I mean, it's weird because if it was nil here, like, let's see. Let's do some printf debugging here. Like if it was nil at this point, we should hit this error. And then if for some reason it's nil here outside the like after the function call, then something crazy is happening. I really can't. This is like as big as it's gonna be, I think. Yeah, look, it's nil here outside. I don't understand. Can you not mutate the state like through a function? What? Do I need to return it maybe? I need to go like, do I need to return this thing? Do the classic in out type. Come on. Yeah, who knows? Okay, so let's just return this object here. Let's return our pipeline descriptor and then reassign it. Let's see what happens. Is this how you're supposed to use what? Are you serious? Oh, I didn't set my return type. Oh my god. It really is. All right, wait a minute. It's nil there still. What is happening? Am I going crazy? This is running, right? Is this code even running? Maybe it's not even running. Maybe it's failing this condition. Or it's short-circuiting. Yeah, it is running. Look, it ran. Test, we saw it. Wow. So this runs. This would error if that were true. Into Vertex program. I don't think so. I shouldn't be, because this is after this array has been like fully filled with, you know, how full it's going to be. 195. This should be getting, yeah. Well, I know this is valid because if this, the check for this is done when the shader's compiled, which is at a different time. And it passes this test here, so it's not nil. Yeah, well, that's what I did here. Well, I tried to at least. This is bizarre. Well, the weird thing is that it's like changing the state in the function, and then that's not being preserved when I leave the function. And this must be some Objective-C type thing going on, because I'm not really sure. Maybe the here, let me ask our friend ChatGPT, who's never wrong, always 100% correct. All right. ChatGPT can never lie to me. I say fully sarcastically. This is something it should be good at, though. Okay, this is a subtle Objective-C arc lifetime issue mixed with C++ pointer semantics. Let me break down carefully. Inside bind shader, you do. Yeah, this isn't it. Yeah, here. But you also set. Wow. But this is a no. This isn't it. Oh, it might be it. I need a static strong. This is so crazy. I'm out of my turf. Okay, so what do? I do the strong one? Because I do have this on, I believe. Arc keeps the reference. If arc is on, strong. Let's try this first. Yeah, because I have this array up here. Here. All right, does this fix my problem? No, it certainly does not. Why would it? One might ask. Okay, so that didn't work. This, do I need to do this? I don't have asand trivially, well actually, yeah, I can try that. 1 second, I do have that working. But first, let me just bash my head a little bit longer. Let's give this a shot, because this is actually making sense to me. If it's garbage collecting this once I return, yeah, it's gonna return the nil. Yeah, no, I already have it hooked up. Let me 1 second. Oh, no. All right, let's hook up the address sanitizer. I already have a config with it, asand. No, we're good. asand didn't catch anything. Let's try. I don't know. So I'm not doing anything too crazy. What else could it be? So this print here, this test is this one. And then the next thing I do is check if this is null. Is this nil? If it is, error. And then I print this message, bind shader. All right. Cool. That one passes because I don't error. But then magically, right outside. Yeah. I should just run with Xcode probably. I don't want to do that. I hate Xcode. Yeah. Okay, so what else could be failing here? So let's see. What else did it say? Did it give me any other hints? What is this? A wrapper? Yeah, I'll try the retain one. This thing? Okay, here, let's retain this guy. This is so crazy. I don't even know what's happening anymore. Oh, yeah, semicolons would be useful. You got a better eye for it than me. API. Yeah, this is just nothing. All right, let me give the whole function to ChatGPT. It's got to figure this out. Come on. I believe. I believe. I give it my completely garbage function. Made by Apple. I have not yet. Maybe I should do that because it'd just be so much easier. Yeah. I had this idea that I wanted to like use Metal the way it was designed. But they have a C++ wrapper that seems so much easier to manage. I completely believe it. Okay, and I will just also give it my little static array, just so it knows that this is what I'm trying to do. I give it full context here. I'm hitting the error. Let's tell it exactly what I'm hitting too, so it knows. Yeah. It's all about your prompt with AI. It's all about the right prompt. Okay, it sees the full picture, certainly. Your arrays, they are all initialized to nil. You never showed how you populate the arrays. This isn't true. The AI is literally just lying. It doesn't understand the code. I know this is objectively false. Like, this is not how that works. Okay, let me see. Let's give it shader in it as well, since it cares about this. Maybe I'm not initializing these correctly. Oh, man. I like to think this is more productive than just trying to figure it out myself. All I want to know is how do I pass? I just want to pass by reference. Why is this hard? Okay, in bind shader, VS is temporary, strong variable local to the function. Assigning does not necessarily retain the object under arc if the property is declared assign or weak in the what? This is why I hate object-oriented programming too, by the way. Like, what is this whole like reference counted lifetime thing? This is crazy to me. Is the function, you know, like when you pass the function, is that not just like a reference to it? Like a handle, right? And Metal should be able to resolve the, like I'm passing it a handle to the function, the vertex program. Why does it need to have a lifetime and be reference counted? And like, it's just crazy to me. I don't understand. Is this easier to program? I don't think it is. This is actually more obtuse. Like, I don't know what's happening. It's like deleting stuff underneath my feet. Okay, what's it saying? Assign does not necessarily retain the object under arc. Okay, so what does it want me to do? Why it happens? Metal objects like vertex function are properties. Check Apple's docs. Okay, yeah, they're a property. If your render pipeline descriptor is not an Objective-C object but a raw pointer. Yeah. Okay, so pipeline descriptor. This is what I have. All right, cool. Okay, so yeah, let's try this. Let's try this. We haven't tried this permutation of the problem yet. Surely one of these will be it. And then once we figure it out, it's just like we're golden because we just do that everywhere. It's just a matter of getting to that point. So we retain. And then we retain. We can delete all of this, delete all of that, delete that. And then I have to make sure to delete that. Oh, wait. No. Too good to be true. Simply too good to be true. Alright, I'm going to return this back to a Boolean. So I guess the question is, do I have retain mode on? What do I have? Output generated. Where's this .mm? No, I don't have retain mode on. I don't think so. No, I don't have this. Well, I will figure this out later. I'm just going to move the contents of this into the main function, because this is like a waste of time to be really worried about this right now. So let's just copy this and put it out. need the resource as well. Kidding me. See, it's not erroring anymore. It's actually like fine, I think. I can't scale the window anymore. Oh, yeah, I can. So it was just a problem with that. Now, I think it did freeze though, maybe. So I don't know if this was actually running for every frame. Oh yeah, it is. So we are getting frames. Wow. I guess in theory, if I debug this with Xcode, do I have Xcode installed? Actually, I should check that. Oh yeah, I certainly do. I can. How do you attach this thing? Open existing project. What is happening? Fluid. What's happening? How do I run this? Debug. Debug executable. I forget how to hook this up to the graphics debugger. Yeah. Okay. I should get out of ASAN. Okay, so let's see. Running metal. So how do you take a graphics capture? What is happening? All right, we have a metal graphics capture, which is exciting. So now we see if any of this API stuff worked at all. So we have a okay. All right, what is this? We have a metal layer and we present, and that's all we do. I guess we're not drawing, are we? The response had no payload. All right. Well, we made some progress. I need to figure out how to use Objective-C. This is really confusing. I wonder why I lost my clear color as well. I had like a clear color thing working earlier. Is it because I did this and then I didn't commit my encoder? Yeah, there we go. Unreal Engine. This engine's so unreal, it doesn't even render. I have a red square. Hours of work and I have a red square. I didn't even make progress. You know what? I'll make it blue. You know what? Why not? Let's do a blue square instead. There we go. Running on bare metal. Yeah, who needs render? Who needs Unreal when you have Jared Engine? You ever want to render every color of the rainbow? Well, I can do it full solid. Who needs vertices? Oh yeah, here we go. We got nice cyan. It's a nice little color. The solution was I just moved code out of the function, and I've decided I'll fix this later. The problem is ultimately that I was trying to mutate that thing in the function. So the no solution yet. I don't know what's wrong, to be honest. Without metal, yeah, exactly. With metal. With bare metal. All right. The next step would be vertex buffers. Am I feeling motivated to do that? I don't know if I am. I might end the stream soon here. I'm getting pretty hungry. Been going for, I didn't realize it's been almost 8 hours, which is actually insane. Because it feels like I've been here for a few. Maybe the guy who was in here earlier was right about how much time this takes. Mr. Woot or whatever his name was. He might still be in here. Hopefully he is. Shout out to Woot Man. You know, we did get some good stuff done today though. I have the shaders actually compile, which is exciting. So we have working metal shader code. We can't see if it works yet because I'm not rendering any vertex data. But in theory, it's binding the layouts correctly. How much work would it be to get the vertex? We gotta at least get a triangle rendering. Come on. That means you need you need the matrices too. You need to do the uniforms. Transpile Rust. I'm using Rust for anything. It's C++. Yeah. Some pretty ugly C++ too. There's Objective-C in here as well. That's what this crazy stuff is. No, not this. This isn't too crazy. It's this stuff. You know, they got this crazy mix of who knows what. You know, you think this is a pointer because it's like Objective C with a pointer, but no, this isn't actually a pointer. It's fake. And I think to actually work with these, I need to define interfaces. Oh, if you looked up GFX, yeah, that's just the name that I've given it. No, yeah, I can explain. I'll actually show something. I'll show something that actually works here. I can't end the day without at least showing off Earth, you know, planet Earth and all its beauty. So this is what the engine will eventually, should eventually be able to render once I finish all the other stuff I need to do. This is using OpenGL. So we got our beautiful Earth in OpenGL, unfortunately. But yeah, oh, mouse look does not work on Mac. Okay, we gotta fix that. What just happened? What's going on? I think my camera roll is all messed up. Here we go. I love how easy OpenGL is as well. It's great. But yeah, the namespace, the GFX thing, that's just what I call the module. I just call it graphics. It's too long to write graphics for every little function call, so I wrote GFX. I was thinking maybe I should do GPU, because that could be fun. It's like GPU work. But I figured graphics makes more sense. So yeah, all the graphics code is like, I'm writing from scratch, which is why this is taking forever to get anywhere. And Metal is Apple's graphics API. And this is on a Mac right now, if you can tell. With my little remote desktop into my MacBook. Can't say I recommend trying to program through a delay. I'm really frustrated by this. I don't know why this doesn't work. I don't understand. I don't even know if this works now in hindsight. I just don't trust anything that's happening with the syntax. When you can't trust what the code's doing, then that's a bad day. But let me see what else. What else do you set? Let's ask ChatGPT. Need to get some information. What is this? So this is MTL pipeline descriptor. All right, so what do I have access to? Vertex fragment, compute. You have the vertex descriptor. All right, here we go. We have a lot of these. Is blend enabled? Destination. Yeah, so these are all the things I care about. It's actually good to know this stuff. Sample count. This is deprecated, which is funny. So it's like hallucinating bad code. You need to use raster sample count. I just read that on the Apple docs. Other metadata. I want to write all of this, actually. I'll do this before I leave. I'm just gonna outline what I need to implement support for. I cannot type, holy cow. Okay, so we have color attachments, depth stencil, rasterization. Here we go. So we have sample count. Wow, there's a lot. And then we have depth stencil, which I think there's a lot more than this. Depth stencil. So there should also be like explicit state alongside this thing. Blend mode. I can just copy this. Oh wow, check this out. Should have done this the whole time. And we have and then what was this? Max. What was this? This thing actually contains a lot of information, doesn't it? How dank my code is. In what way? I'm curious what you mean by that. Because that could mean a lot of things. Alright, here we go. It's a big project, I'll say that. Slowly chipping away at it piece by piece. One day at a time. Alright, I did not copy the raster state. I missed that, did I? No, this should be up here. Yeah, it is very dense. There's a lot going on. God bless. ChatGPT can't, web dev can't handle basic text input. Isn't that funny how that works? It's like we have, our computers are so fast nowadays. It's like supercomputers, right? And you can't even handle text input. It's crazy. All right. Yeah, this should be here. Scissor state isn't handled by this guy. All right, and then we make this thing up here. All right, so this is all the state I need to actually account for, basically. Sample count. I don't know if these are actually true though. I'll need to verify these with the docs before I just start using these. But they make sense. Alpha coverage converts alpha 1. This is such a weird alpha to 1 enabled. Yeah. Oh, these are part of color attachment. So this is like descriptor dot. So those are per descriptor, per wow, this is crazy. Well, you're welcome, I guess. Let's see. Is this really true? Is the right mask and blend modes by the render target? That can't be true. I don't believe this. Okay, I'm gonna ask ChatGPT the same question now, but for the MTL render pass descriptor. Is that the one I just checked? No, I need the okay, yeah, let's do this. This is not the same window, is it? So you have 8 color attachments. It's interesting. So let's just sketch this thing out again. Because this is good information to have. Because otherwise I'm just confused all the time. Global landscape form. What does that even mean? Global landscape form. Oh, there's a stencil attachment too. Yeah, classic. All right. And the stencil descriptor. Okay. GLF. GLF. All right, here we go. I mean, to be honest, the Metal API is kind of nice. Like, looking through this, it's not a bad API. It's like the pain point is this Objective-C stuff that I just don't understand. Like, I don't even know how to work with the code. I spent most of my time trying to like figure out how to mutate a value through a function call. All right, what else did I have here? I think that was it. All right, but I think I'm going to end the stream for today. I've been going at it a long time. Just crossed the 8-hour mark, so I need to go eat. I have other stuff I need to do before the night's over, which is unfortunate. But thank you guys for stopping by. I appreciate the conversation. Definitely makes this a lot more fun. Otherwise, I'm just sitting here grinding away, trying to figure this out on my own. So, but yeah, I'll stream again probably sometime middle of the week, I think, and then next weekend probably. We'll see. But yeah, thanks guys for stopping by. I'll